day. Innovation shaping our fate, together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Of the galaxy where the stars align, we gather as a community with a vision so divine. Panoramic views, a world we can explore. With Liquid Galaxy, we open up the door. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide. Spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe draws near. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide.
Hello, my name is Abhishek Chaudhary. I am a third year BTech student in computer science with specialization in artificial intelligence and machine learning at Kiarmangalam University. My proposed project is called AScape. AScape is an environmental intelligence system for Liquid Galaxy platform. The main idea is to make environmental data easier to understand and more interactive. There have been many projects that focus on different parts of environment such as education, automation and awareness. In this project, I want to combine all of these ideas together into one system. I will be working with data like pollution, weather, traffic and forecast data and using it to create interactive 3D visualizations on Liquid Galaxy. So instead of just showing numbers, I want users to actually understand what is happening in a city and how different factors are connected together. Users will be able to explore a city, compare different sites, use a timeline to see how conditions change over time. They will also be able to switch between different layers like pollution hotspots, traffic data, forecast data, and ranking so they can look at multiple factors together instead of just one. I also plan to include historical data so users can see how pollution has changed in the past along with forecast data to get an idea on how conditions might look in the near future. One of the main parts of the system is the AI-based exploration mode. In this mode, I will use an AI model to guide users through the data in a more structured and a story-like way. Instead of manually exploring everything, the system can explain what's going on, like why pollution is high in a certain area, how weather is affecting it, and what patterns can be observed. It will include interactive quizzes during the explorations so users are not just passively viewing the data but are actually engaging with it. This makes the experience more interactive and educational rather than just a visualization. The system will also support voice commands so users can control the application and navigate between different features more easily. Another thing I want to include is the dynamic city support where users can search for any city and the system will generate visualizations for it automatically. For the technical flow, I will fetch data from public APIs like OpenAQ, OpenWeather, and OpenStreetMap and process it inside the Flutter application. Then I turn that data into KML files and send them to Liquid Galaxy using SSH. That's how everything shows up across all the screens together. This way the system stays smooth and consistent across an entire setup. Overall, the goal of AScape is to make environmental data more interactive and easier to explore and actually useful for understanding what's happening. So with AScape, I'm not just trying to show environmental data, but make it something users can actually explore and understand in a more meaningful way. And that's what I'm aiming to build with AScape on Liquid Galaxy. Thank you for your time.
Hello Liquid Galaxy team, my name is Amit Verma and I am from India. I am currently pursuing my Master in Information Technology from IIPS. Today I am presenting my proposal for Google Summer of Code 2026 with Liquid Galaxy. My project title is Liquid Galaxy Glacier Melt app. So this project focuses on a visualization glacier melting and rising sea level using the Liquid Galaxy platform. So the goal of this my project is climate change easy to understanding user using visual storyline. I will user storyline. So I build a Flutter based application to that connected with Liquid Galaxy and Google Earth. So the system will showing the glacier melting over the time and rising sea level using the 3D KML animated and colorful changing based and melting intensity. So user will able to explore and past and future and present data with different glacier region and understanding the impact of climate change and interactive way. So this will create a immersive multiple screen experience. To build this app and project, I will collect the real data from source like a Nova. So then I will process data and convert it into a KML format for visualization in Google Earth. So I will implement it fly to camera movement which smoothly navigate between the glacier region and creating a cinematic experience. So my project for also included AI voice narration. So it will be guide user and explain what happening on the screen using the text and speech with improved user engagement and understanding. So this project is very important for Liquid Galaxy because it's add a new real world use case based on a climatic visualization. It help to Liquid Galaxy move behind a simple demo and become a powerful education and research tool. It also show how Liquid Galaxy can be used storytelling using a real-time historical data. And additionally, this project can be attract student research and organization who wanted to use Liquid Galaxy for environmental awareness in the future. So the system can be extended to the other domains like a smart city, disaster management, and a live monitoring systems. So this project is specially because it use a real climatic data and transfer complex information into a simple powerful visual story. So it's combined a map, animated storytelling, and create a strong visual impact. So I believe I am a strong candidate because I have a skill at Flutter, I have a skill and data visualization. I am highly motivated and successfully complete this project with good communication and quality work. So thank you for watching. I am excited to contribute with Liquid Galaxy. So thank you.
Hello everyone, my name is Kabir Khanoja. I'm currently a computer science student studying at VIT Pune. And I'm applying for Google Summer of Code 2026 with Liquid Galaxy. Well, when I was in a search of ideas for the proposal, I went through the list Liquid Galaxy provided. Not gonna lie, there were a ton of ideas that intrigued me, like the Jurassic Tour Explorer, Educational Tourist, UNESCO World Heritage, and many more. And as much as I wanted to work on all of them, I thought to myself that, hey, why not build something as a concoction of all of them and even more? That's when I thought of AI2 Director, an omni-agent system for Liquid Galaxy. The goal of my project is clear as a bell. to build an intelligent system that can transform a simple user prompt into a complete immersive tour experience. The user can simply enter a prompt like historical places in Pune, and the system automatically generates a complete tour, including the locations, the sequencing, camera movements, narration, the subtitles, and much more. And it's going to remove the need for manually creating those KML tours, like the ones that I mentioned, the projects, and make the whole experience more accessible and dynamic. Though I'd like you all to witness the UI of the app. So basically, okay, this is the home screen, right, where the user can go and prompt anything that they want, just like I have done here. It would then fetch the locations. It's going to be a Gemini call. It's going to fetch certain locations. The locations would be present there. The user can go here in the immersive mode. They can inspect the scene here. And this is basically Google Maps, which is in sync with the LG rig. So before the tour, they can completely see all the locations that are there. And then once they are happy with that, they can start the immersive tour. Now, as the tour starts, there are going to be subtitles that are present on the screen, and you can see where exactly on Google Map is this particular location. But for the rig, this is going to be the starting scene where you get an overhead of all the locations that are present there, right? Okay, so these are all the locations. You even have a certain description, the tour highlights, and these KMLs that stand out with the logo. You're gonna have a look at view at first, again with a contextual imagery, certain subtitles that are gonna also be present on the screen, and then you're gonna have different scenes. This is like a top view, and this is the orbit view. So this is the basic start of the app. Well, great. But hey, I've seen such ideas with respect to dynamic KML. So what more does this system has to offer? Well, what makes this project special is that it doesn't just generate tours, it directs them. Now, this takes me back to my film school, Film and Television Institute of India, that I was a part of. So I wanted that this project should not only give a cinematic experience to the user with the LG rig, but to the whole world. So I went to Liquid Galaxy's YouTube channel, that is this, and I was like, I gave it a thought that if this was filled with many educational, historic, and amazing films altogether, that's where the shareable video part kicks in. Now, the system has the ability to record immersive tour and provide a 1080p cinematic video experience of the tour with subtitles, so that it becomes a key app, not only for a movie-like experience, but also for producing content that you can then share on YouTube, WhatsApp, Google Drive, anywhere that you want. So this is the UI screen after the tour is over, when the video is getting processed. The user aren't left high and dry. They are on the screen where they get the post-credit scenes from the tour. This is the Google Map API again. They can get to know about certain facts, right? They can again move around. This is how the video is produced. They can share, they can download anywhere they want, and there's a history as well. This is the tour library. They can select any tour that they want. They have been in the past. They can start the virtual replay, get certain highlights of the album. And then there are multilingual options and certain dark modes that they can explore in settings. And this is the basic UI of the app. Again, now there's a flock of agents, starting with the first agent, the creative director, which helps narrate, which helps with all the scenes in the start with all the locations. There's production designer agent that sets the camera paths and creates the KML. This is a writer agent that creates narrations and subtitles via AI, Gemini call 2. And then there's a DOP agent, director of photography, which helps with the recording and, you know, the whole MEG of tour, right? And Google Maps API, of course, is there to integrate this all with the whole map kind of system. So AI powers both structured planning and story-driven narration, and hence this transforms Liquid Galaxy Tour into something that's related to storytelling engine, and it creates a whole cinematic experience for the tours that can be saved as KMLs and also be shared as videos. Well, I'm really excited about this project and very confident about executing it. So I'll see you all on the other side. Thank you.
Hello Liquid Galaxy community, this is Soumya Sagar, and this is my project. This is my submission for the project of Liquid Galaxy Gemini Summer of Code 2026. I present to you the Agentic starter kit that the prompt asked for. So I didn't just build any application or something like that. I just built a system that can analyze a project and that can replicate that project into a Flutter starter kit. So I analyzed the requirements from the GSoC video, the .agent skills folder, and also I built, I tried to basically train the whole AI to write the clean and clear codes, try standards and solid principles. So let's dive into the code, just because the code base is where the agentic AI magic happens. So let's switch. First of all, here is the code base. You can see Liquid Galaxy. Basically, I renamed that folder is like Liquid Screen, just because I have a lot of folders. So don't waste time. So basically, see, here is the folder structure. You can see that I have divided the whole thing into two different thing. First, first the starter kit, in which we can replicate any sort of thing, any sort of project into a Flutter starter kit. So it's a basically template kind of thing. And same thing, but here, this is the demo earthquake app that I made from anti-gravity from this Flutter kit. So you can see the whole code base. Let me first switch to the basically the demo earthquake app. Let me show that in the local host what I have built. Okay, so yeah, here is the local-host website. That website, I can't say it is a website. I can say like it is a Flutter API, Flutter kit basically. So see, it have two sections. The first, earthquakes, and the second, space tracker. So this is how you can make multiple things in an app. So in a Flutter kit kind of thing. So basically, let's switch to the earthquakes. So here is the map of the world, and here are the country names or something like that. And here is the magnitude, or we can say what's the magnitude of the earthquake that hit in these regions. So you can see this is the basic app. So, and let's switch the space tracker. That is my favorite. So I built this. See, you can see that multiple satellites you can revolving around the whole Earth. So you can see the live movement of that thing. So this is the whole showcase of the app. Flutter kit, to be very specific. So now switch to the main part, explaining part basically. So I used a feature first architecture to make it easy for agents to navigate. So basically, see the live folder. You can see here in like earthquakes, there are many features. Okay, so here are the folders, earthquakes, and also the space that you are seeing in that like in this thing. So this is how I bifurcated every feature. So if you want to add any other features, you can add to these to this thing. So it is very basic thing. You can do everything from this. So now, if an agent wants to add a new feature, say like weather, okay, so it just creates a new folder here. So we can create a new folder like from here. Okay, so yeah, from here. So like wait, let me show that thing. This is how I classified the whole thing, the feature card. Okay, so firstly I strictly followed the don't repeat yourself principle. For example, look at basically this thing. Instead of repeating the UI code in the home, screen, I extracted this completely. This means if an agent creates a new feature, so it just calls from here, and every UI after calling this remains the same and be consistent. So this is how I curated the dry, don't repeat yourself thing in this. So let's switch to the other folder. Now here is the inside the core inside the lib and inside the core we have a services section. What does this do basically? Um, Agents certain time agent struggle with connection management. So basically I centralized it here. So that um basically everything got centralized. So for that, I used a singleton SSH service in this lib and the core folder, which does the app handles the connection state globally, so the features don't have to worry about it. So if any feature got implemented, every connection from this folder, from this file, got transferred to that specific thing. So now switch to the other folder. Now talking about the features, so let's switch back to that specific, basically we can say to that specific app that I have built. Sorry, the Flutter app, the Flutter kit I have built. So let's switch to the earthquakes section. Now let's look at the earthquake tracker. This fetches real-time data from the USGS API. Now, so here you can see all the things that I already showed before. Now, I didn't stick to standard markers. I customized the whole map to use satellite imagery. That is called Esri world imagery to match the liquid galaxy experience. The red circle scaled dynamically with the earthquake's magnitude. So we can say if any region got like 1.2 Richter scale magnitude, it is slightly less in compared to this 4.6 Richter scale magnitude of earthquake. So this is how I handle something. So now if I click this thing, let's click this 4.6 thing or something 5.0. Now here is the basically the integration. When I click this 5.0 magnitude quake, it sends a KML fly to command. Basically the KML fly to command to the liquid galaxy rig. Okay, so on the liquid galaxy, this flies the Google Earth camera directly to the epicenter and draws a visual radius. So this is how I integrated the KML structure. Now switch back to the home page and now click to space tracker. You can see the whole world. The whole world, yeah, no. So the prompt asks for something better than the example. So I built a real-time space tracker. You can see by pointing to ISS icon, this isn't just a static app. I implemented the SGP4, the math model. The full form is like simplified general perturbations. So in the directly in the Dart app. So the app calculates the live position of the ISS and other satellites at the time of 30 times per second. So you can see the latency and all thing, how it basically transition from here to here. So this is what built. So let's switch to the code base part. So let's switch to the features, and then in the space folder, and then in the wait, let's yeah, the more models part, and then the satellite model.dart. This is the SGP4 math model that I am discussing about. So you can see this math model here. We parse the TLE data from Celestark and propagate the orbit in real time. So basically, if you see wait, sorry, I've basically backed that thing. Let's see the ISS thing. Yeah, this is the ISS, International Space Station, that we see. So basically, and look at the visuals for the ISS. Tiangong जो भी है, the ISS object zoo, and basically this fetches the real photos in the liquid galaxy screen. So when I click the ISS, it generates a dynamic orbit path KML and beams it to the liquid galaxy screen. So this is how KML is also working in this part of thing. So let's switch to the code base. So this is the whole contribution part, like how the future agentic AI built, or we can say contribute to this thing. So basically I created this contributing.md file. This is a guide written specifically for future AI agents. It explicitly defines the plan, that what is the plan for this app, the task, that the features also, the architecture, then how to execute and how to verify. The whole workflow is mentioned in this part of the file, or we can say the contributing.md file. So it explains basically the folder structure, the coding standards, and how to register new features. So we can see the folder structure here and the coding standards, that how to maintain the whole part of the system. So at last, the conclusion part. This project meets all the GSoC criteria. Agentic architecture, that is for ready for AI expansion. Code quality, dry and also the solid. Real world integration like APIs plus KML plus Liquid Galaxy screen. So I'm ready to build the future of Liquid Galaxy tools. So thanks for watching, and have a nice day or night ahead. So thanks.
Hello, my name is Josep Miquel Serta Esteban. I'm studying multi-platform cross development at Ilerna. I am 20 years old, and my proposal for the GSoC is named Geosaurio. The goal of my project is to let the users know more about dinosaurs and be able to explore where they were found in a geographic way. So they will have data like the type of dinosaur, the height, the weight, their diet, and the time they live. So this data will be saved on a database, and I will use KMLs to show them on the Liquid Galaxy. Also, I will use AI to be able to narrate some of the dinosaurs information, so the user doesn't have to read it and can listen it more easily. I will also have a 3D model that the user will be able to look at it at the Liquid Galaxy. I will use chromiums to make it able to send to the Liquid Galaxy a comparison between a dinosaur and a human being, and also I will be able to send the picture of the fossil that it was found and the recreation, how it's think it was the dinosaur on its time. Also, I will use the IA and Agentic AI to try to make some experiment of a replication of my application on Flutter on web. So I will be using only prompts to this Agentic AI to try that it could generate my application in this way. I think my project is special because it's a different way to learn about how dinosaurs live and to learn about it in a more interactive way. Also, I think my project should be selected because I think it adds another educational way to the Liquid Galaxy, and how I said, it's an interesting way to learn about the dinosaurs in a more interactive way for the users. Thank you for your time and goodbye.
Hello, my name is Chang Do Thuy. I am originally from Vietnam and currently living in Barcelona, Spain. I'm a student at FP program in multi-platform application development at University and also a student of web and software development course as Migra Code. And I am a wannabe contributor for Liquid Galaxy Lab for GSoC program this year, 2026. And today I'm going to talk about my proposal, which is Red List Endangered Species Living Atlas. So the goal of my project is to transform the raw data into and visualize them so that it's more accessible and interactive for everyone, so that we can raise awareness about our currently urgent issue, global issue, which is biodiversity loss. And the way we're gonna do it is first we fetch the raw data from the Red List API, and then we process the data and store them in our database, which is Hive, and later we're gonna generate the 3D colorful KMLs and display it on the multi-screen in an orbit mode. And to achieve this, we can build a Flutter Android applications, as you can see here. So it acts as a remote control, so that whenever the user interact with the phone screen, it's gonna trigger and display the information on the multi-screen. And we're gonna have three main modes, which is explore mode for the current data, also the history journey, so that we can slice over the timeline to see the number of species shrink over time. And we also have the future threats, which is the looking ahead feature, so that we can see the future danger and also receive tips and suggestions about conservation. And we also have the TTS voice along every features. And we also use the AI implementation here. To be more specific, we're gonna have a chatbot feature which is AI empowered, so that whenever the user chat within it, they can get the response immediately, and it is can be achieved thanks to the help of Google Gemini. And also we're gonna use the AI here when we process the data and transform it into storytelling, and also for the conversation suggestion. And I think this is a very potential project because currently this is a very urgent issue. However, not everybody is interested and even knows about it. So my goal is to transform it and visualize it. And thanks to the modern technology of Liquid Galaxy, we can display the information on our multi-screen and make it like more impressive and also interactive. And we can use it for the educational purposes, such as for example, we can use in school, zoo and museums, so that user can at every age, and they can receive the information and knows more, and also know more about the biodiversity loss, and also about the suggestion in the future. And that's all, everything about my presentation, and thank you for listening.
Hello, I am Jan Sanchez. I am currently studying a vocational training called Cross-Platform Application Development, and I am going to explain to you my proposal for the Liquid Galaxy project. Firstly, I am going to explain how I'm going to make this application, Basically, I am going to make it on Flutter with SQLite. This is going to be on local, the database. Okay, so I'm going to explain to you how I'm going to make this application. Basically, this app is going to be, you're gonna have a timeline which is gonna be past, present, and future, and which one you're gonna choose. If you click a point of interest, for example, I make this mockup with Spain. If you click present and you click Plaza Mayor de Salamanca, well, this is going to be what is going to appear. If you click future, and you can, there's all these buttons that you can choose when you click this application. So it's compared with present or another point in the timeline. So if you're in the future, you can compare with the present or the past. And AI narration, which will be what is displayed in the Liquid Galaxy, the description or whatever is in the text. And AI is going to display the text for you. And you can orbit around, which when you're displaying my application, a huge image will be shown in the Liquid Galaxy. And when you do the orbit, that image is going to disappear and you can see the orbit of the place around. And finally, the statistics, which is going to be a statistics of the comparison. So basically, if you go to Sagrada Familia, well, it will be like the height, well, statistics of the place, right? So now that I've shown you what my application is going to be for, I will explain to you that I will have to make an extra task with Agentic AI. And well, basically what I will do is with Agentic AI, I will create my application that I have already made and I will make it in web, right? So that will be all for this project, and thank you all for listening, and goodbye.
Hi, I'm Anirudh Pratap Singh Yadav, a second year AMS student from India. I have submitted 3 proposals for GSoC 2026 under the Liquid Glacier organization. This video is for my third and last proposal, which is Ocean Echo LG. This is live ocean noise pollution visualizer, and this one is like quite different because this one is genuinely concerning for me and it should be for you as well. Let me ask you like one simple thing. Like when you think of the ocean, you think of peace and quietness, right? It's like still and like peace, right? So waves, maybe some whale sounds, but the reality is very much different. Like it is completely different. Right now, as we speak, there are over 250,000 vessels on the ocean, and a like single cargo ship produces up to 190 decibels of noise underwater. Like that is louder than a jet engine, and that noise travels thousands of kilometers through the water. So like ocean noise has been increasing since 1950 after the World War happened, and whales, dolphins, marine mammals depend entirely on sound to communicate, navigate, find and eat food or survive. And like we are drowning them out completely. So the problem is truly very much, and like it is in the larger scale. Like so I thought of the Liquid Galaxy rig, which is a 5-screen panoramic display. I'll just show you. Like these are some of the mock-ups which I created. You can see this affected area, and like this is on the Google Earth and this is on the rig which will be seen. These are some 3D KMS. This is the first screen is complete of logo, and the solution intelligence powered by Gemini is on the 5th screen. And you see the effect, like this is old effect, and this is crazy thing. Like you see the ships, right? These are from state of Hormuz and completely. So that is Ocean Echo LG for you. And like Flutter app on your LG, I'll just show you. There are some apps also, like this sea Southern Ocean is 37 countries joined the high ambition condition for a quiet ocean. Like you can apply a filter like a cargo ship you want, or maybe next naval length. This is AI story panel because it should be storytelling, right? It is powered by generative AI, which is Gemini, and the GCP component was given to me by Andrew. So like it is completely built with free data sources like AI stream.io for live ship positions, WebSocket, GBIF for real marine mammal sighting coordinates, NOAA for acoustic monitoring data, and like Ocean Network Scanda for real hydrophone audio recordings. Like everything is processed entirely on the phone, and like there's no backend, no cloud, and just Dart engine rich KML layers and pushing them to the rig via SSH in real time. Like port can be different, but yeah, on the rig you see the full picture across all 5 screens, and there's a like live noise heat map, green for quiet zones and orange for elevated, red for critically loud regions above 150 decibels. So the blue whale I showed you is something different, and that is where like species are being pushed out of their feeding and breeding grounds. And like this project is really very concerning, and it should be a storytelling. So like it plays actually actual hydrophone recordings, and like Rick shows you the North Atlantic shipping corridor of maybe 155 decibels to 180 decibels, and like your phone plays you what the actual sounds like underwater. So it's basically the sound, and it's never done on the LG rig before, but it was done in like previous year regarding the supply chain monitoring. But it can be further done using ocean rig, like storytelling. It is very much, and as you see in the world as you see in the crisis happening these days. There's also like Strait of Hormuz is closed, right? You can show like this is for the audience. So Gemini 2.5 Flash takes the live data and generates a real contextual environment briefing, and like every ship is real, not hard coded. This is all the live data, and like I care deeply about this proposal, and I hope you you do too. And like if I get selected, I will build this with full seriousness it deserves, and with the support of Liquid Galaxy organization and my mentors. Thank you. Namaste from India.
Hello everyone, I am Tanishq Sharma, a third year undergraduate student from India. I am currently pursuing my bachelor's in engineering from Punjab Engineering College, Chandigarh. This is my submission for Project Defense Day for GSoC 2026 for my proposal Aerospace at Liquid Galaxy Lab. Air pollution data exists everywhere, but for most people it's just raw numbers on a screen. It's hard to truly understand how pollution behaves, how it changes over time, or where it comes from. My project Aerospace aims to solve this by transforming air quality data into an immersive, interactive experience on the Liquid Galaxy platform. At its core, Aerospace is a real-time geospatial visualization system designed specifically for multi-screen panoramic environments like Liquid Galaxy. The system is built around three main components: a data pipeline, a processing layer, and a rendering pipeline. The data pipeline fetches both live and historical air quality data using geospatial queries based on the user's viewport. The Liquid Galaxy rig will return us the user's viewport, that is the bounding box that the user sees, and then we create a query and get only the data of the monitoring sites within that bounding box. So instead of loading everything at once, the system dynamically updates whenever the user moves the screen, that is, whenever the user navigates. This helps with efficient API usage. This data is then processed into dynamic KML structures which are rendered across multiple synchronized screens in Liquid Galaxy. Monitoring stations are visualized using 3D elements like pillars and disks, where color and height represent pollution intensity, as we can see in the image behind me. What makes this project different is that it doesn't just display data, it also explains it. One of the key features is the historical story mode. In this mode, users can select a time range and watch how pollution evolves over time. The application generates a 3D KML tour, and the user can live through the time range and see how the air quality changed for that monitoring station. Uh, it also has an anomaly detection engine that identifies unusual spikes, allowing users to focus on critical events rather than just raw data. Another important feature is the wind-driven pollution analysis. The system uses wind data to backtrack the path of air movement and identify possible pollution sources such as industrial areas or wildfires. This shifts the experience from passive observation to active investigation. To enhance accessibility and engagement, the system also includes AI-generated voiceovers that guide users through insights as well as health advisory information tailored to different pollution levels and different age groups. From a technical standpoint, the project integrates multiple APIs including the OpenAQ API for pollution data, OpenMeteo for wind data, OpenStreetMap for geocoding, and NASA's FIRMS API for wildfire data. It also uses a viewport-based caching mechanism to reduce redundant API calls and maintain performance within the rate limit. So let me quickly demonstrate how I plan to make the rig look like from a little closer. So you can see in this image the rectangular pillars and the discs around it that represent the AQI. This is another mockup that I created. So this is how I plan to make the rig look like with my application. So this is for all for my project Aerospace. Thank you.
Hi, I'm Niru Pradhan Singh Yadav, a second year AIMS student from India. I have submitted 3 proposals for GSoC 2026 under the Liquid Glacier organization. This is a project defense video for my first very excited proposal, which is LG Arkanoid multiplayer panoramic game. So everyone has played Arkanoid at some point, right? So that classic brick breaking game, all simple, fun, and addictive, but like you always play it into one small screen, which is a phone. I don't have phone because I'm recording it there. So I thought, like, what if we take that same game and spread it across 5 giant phantom screens? You just see it, right? This is my mock-up, which you can see 5 screens. First is the logo, and like 3 screens you play directly. Where your phone is the controller. Like this is the LG Arkanoid. The whole Liquid Galaxy rig becomes one big breaker, and the ball travels across all 5 screens. Let me show you one mock-up. Yeah, like see, the 3 players are playing, and like ball travels to the 3 screens and works it, and they each control their own paddle from their phone, and just drag your finger left and right. If I could show you some of these are the scores, and this is the splash screen basically, and this is the level screen cleared mock-up. So let me talk about how this actually works. Like the game is built using phaser.js on HTML5 canvas running inside Chromium on each LG screen, and a node.js server with socket.io sits on the LG master node and acts as a single brain of the entire game. It sends the full game state to all the 5 screens 60 times per second, so everything stays perfectly in sync. And the Flutter app, controller app, which connects via WebSocket, sends paddle position updates 30 times per second. So basically, there's no lag. And the biggest challenge which I could face is which the project is genuinely hard, is the ball crossing between screens, because you see the ball can cross between screens, right? It has to cross between screens, so it has to be perfectly synced up. So what we have to do is that I will solve it using the single frame. Like the ball will be between the screens, and when the ball exits screen 2, it must appear on screen 3 at the exact matching position within a single frame of maybe 60 FPS. So if there's even a tiny delay, the illusion of one continuous world completely breaks. So the moment the ball crosses, the way I solve is Node.js, and Node.js servers handles boundary detection centrally. So the second challenge is keeping 3 phone controllers perfectly in sync with the game without any noticeable lag. I can tackle this by keeping the phone as a pure input device and no output, only the controller thing. So this keeps the communication very lightweight, and the game responsive is even on a local network. Then there's a very much like creative thing I would say. I use Gemini 2.5 Flash. I got the GCP coupon from Andrew sir. So it for a live commentary, like it will just do live commentary. It will showcase a full live commentary. If I could show you, yeah, see. Yeah, see, the PA1 is dominating with a 3-1-4-0 point lead, multi-wall incoming on level 2. So this is a pure, like it just shows on your screen and reads aloud on your phone via Flutter TTS, which is used for voice and automatically, and then all of this runs on a redeemed GCP voucher. There are 3 levels, 3 players, and 1 panoramic screen which is visual. And like I'm very sure after hearing this, you are all pretty excited, because I'm 2, and then I promise you, if I get selected, fingers crossed, I'm going to deliver the game for the gamer Gen Z. And thank you.
Hi everyone, I am Sailesh Kumar Shukla from Ghaziabad, Uttar Pradesh, India, currently in 6th semester pursuing BTech in Computer Science from IMS Engineering College. My proposal name for GSoC 2026 is Liquid Galaxy RPG, a multiplayer 2D fantasy game. In this project, we are going to build a real-time multiplayer game, which is divided into 2 game modes. The first one is King of the Hill, where 4 players divided into 2 teams of 2 compete in a PvP match for capturing a castle. The second one is Dragon Raid, in which enemy spawns and player work together to survive and defeat the final boss. The AI integration in this project is a NPC character which explains the game rules and mechanics at the start of the game, which is suggested. This idea is suggested by the mentors. The second one is the AI cheerleader, which going to send a motivational message to each player personally, based on the game events like kill streak or low health. To build this, we are going to follow server authoritative model, where the Node.js server act as the command center, which run all the game logics and serve the game on each LG screen simultaneously. Now each LG screen simply open the game on the Chromium browser and horizontally shift the camera view depending on the screen number, so the game feel continuous across all screen and smooth. To answer the question why this project is unique, it is likely the first ever RPG game on the Liquid Galaxy with two game modes. First one is the King of the Hill, and the second one is the Dragon Raid, and a NPC character which explain all the game logics, and a AI cheerleader which personally send motivational quotes. Now I'm going to show you the mockups to get the visual idea how the game will look like on the Liquid Galaxy screen. So first mode is King of the Hill, where two teams are competing for the castle. Now here you can see they are fighting each other. There is AI coach or cheerleader which motivates them. Now the team star has won. Now the second mode is the Dragon Raid, in which skeletons and zombies are spawning and players are fighting together to survive. The wave 2, where armored skeletons are spawning. Now final boss and then raid complete. Thank you.
Hello everyone, my name is Deep Buha and I am a second year undergraduate at IIT Gandhinagar majoring in computer science and engineering. My GSoC proposal for Liquid Galaxy is titled Urban Flood Risk Mapping for Liquid Galaxy. The primary goal of this project is to build a Flutter-based controller that allows user to select any city globally and instantly visualize its flood risk. The risk is projected onto Liquid Galaxy rig as a 3D color-coded KML polygons. The visualization scales from green for low risk to yellow for medium, orange for high, and red for extreme risk. The app supports live mode for current data, a tour mode for fly through multiple cities, and comparison mode. You can see that here. That is red for extreme, low for green, and this is orbiting, and we can fly through two cities, and we have this color coded camel shown for cities. Yeah, to make this visualization accurate, the app requires a robust data pipeline. It fetches real-time river discharge, return periods, hourly precipitation, and elevation data globally using the Open Meteo APIs. Once the data is fetched, the Flutter app's risk engine evaluates these metrics to assign a strict risk classification. From there, a custom Dart KML generator translates these risk levels into 3D extruded polygons with mapped colors and varying heights based on the return periods. Because the Liquid Galaxy operates on a master slave architecture, the Flutter app will connect to master node via SSH, and it then pushes the generated KML files directly into the directory. We can then upload many commands to it. Then what sets this proposal apart from standard data visualization is deep integration of Google's Gemini AI to create intelligent analysis layer, which is shown here. We can see that it gives AI summary. Then finally, the app utilizes Gemini for predictive classification. It moves beyond simple static thresholds by taking discharge and other data and provides logical reasoning for its decisions. Then, so we can see that we have this orbiting speed. We can compare between two cities. We can compare the same city with different environment, and we can, yeah. So we have these KML extrusions coming up here as we want to show. You should choose this proposal because I have the exact technical foundation required to execute it without delay. I already have practical hands-on experience with generating KML for visualization and building presentations specifically for Liquid Galaxy. Furthermore, I have built complex multi-agent LLM pipelines and automated system using the Gemini API in previous projects, meaning the AI risk summary and classification feature are already within my proven skill set. Finally, I am an active competitive programmer holding the rank of specialist in code forces, which ensures I can write highly efficient algorithms logic for that KML rendering engine. I have the 20 hours per week availability required for in June and May and June. The necessary skills and concrete architecture are planned out. Thank you for your time, and I look forward to contribute to Liquid Galaxy in this summer. Thank you.
Hi, I'm Niru Pratash Singh Yadav, second year AM student from India, and I have submitted 3 proposals for GSoC 2026 under the Liquid Galaxy organization. This video is my second proposal, which I'm truly astonished about, and this is LG RPG. This is a multiplayer panoramic role-playing game. I wonder everyone here has played an RPG at some point, right? Like Zelda, Pokemon, Stardew. You're dropped into a world, you explore it, you fight it, and you grow in it. Right? But there's always one thing, one limiting thing which you experience it, which is your phone. You just play in a one small screen, right? The world never truly feels big. So I thought, what if the world was actually big? What if your hero literally walked across a physical room of screens, maybe from screen 2 to screen 3 to screen 4? What, right? So I just created a mock-up, which is a village, open plains, a forest, and a dungeon entrance, each spanning 1 or 2 entrance or maybe screens. So 3 players each control their own hero from across all the 5 screens from the controller app, and the game, no visuals on the phone, only the controller. I'm gonna show you some mock-ups quick, right? Let me just zoom in. Yeah. So this is LG RPG's main thing, and this is a forest, and this is a basic. Yeah, so after the player wins, there's 3 winners, it's undecided, right? And these are some mockups, this is a controller as you see it, spell, item, attack. So yeah, so the game runs on phaser.js and HTML canvas inside Chromium on each LG screen. So it holds every player position, every enemy location, and every quest flag, and broadcasts everything to all 5 screens at 60 FPS via socket.io, and the screen holds very zero state, so they are pure displays, and this means that they can never fall. And the biggest technical challenge is the hero crossing screen boundaries, right? So when your hero walks off the edge of a screen, they must appear on screen 3 within at least exact matching position with a single frame, which is 60 FPS, right? So it detects the server handles. So what I did is we created only one server. So it detects the boundary and notifies both screens in the same broadcast. So both update in the same frame, which is only single frame. So the second challenge is the cooperative pressure plate puzzle. In the forest zone, the puzzle requires all 3 players to stand on 3 separate lines, if you know the game. So on one screen, this would feel routine, but across 5 screens, it becomes very spatial, and players have to split up, so communicate and coordinate. So this is the biggest challenge. But then the AI layer we have, instead of fixing NPC dialogue, when a player talks to any NPC, the Flutter app actually have an inventory to Gemini 2.5 Flash. Gemini returns a short contextual response that reflects the real game state. So the village elder speaks differently after you defeated enemies. So the Like there are 4 biome regions, 3 heroes, 1 continuous world across 5 screens, and like this is the first multiplayer RPG ever built for the Liquid Galaxy rig. If this gonna be succeed, so I'm sure after hearing this, you all are like pretty excited, because I'm very much, and like I can promise you, if I get selected, fingers crossed, I'm going to bring this entire RPG world real time to life across the Liquid Galaxy rig with the full support of the Liquid Galaxy mentors, organization, and Andrew sir. Thank you. Namaste from India.
Hi everyone, my name is Aniket Dhingra and I'm currently pursuing computer science engineering from VIT Pune, India. Today, the proposal I am presenting is global cyber attack visualization. So the problem is that today most cyber threat tools rely on 2D flat dashboards. They show numbers, but they don't show context. That's where Liquid Galaxy becomes powerful. Cyber attacks are global, dynamic, and spatial in nature, but current tools don't reflect that. So the goal of my project is to build a system that collects real-time cyber threat data, maps it geographically, converts it into 3D KML visualization, and displays it on the Liquid Galaxy rig. This allows users to not just see the data, but experience cyber threats spatially. Now let's understand how the system will work. So the system has 4 main components. First is the data pipeline. I will fetch cyber threat data from public APIs like Abuse IBDB and Alien Vault OTX or Grey Noise. This data includes malicious IPs, timestamps, and attack types. Then I process and normalize it and convert IPs into geographic coordinates using GeoLite 2. Then comes the KML visualization engine. Once the data is processed, I generate dynamic 3D KML like attack arcs between source and the target, color coded intensity like green where attacks are less and red where attacks are more, heat maps and markers. This KML is then sent to the Liquid Galaxy rig via SSH. So the last component is the Flutter controller app. The controller app allows users to select locations and fly to them on the LG rig, view real-time stats, explore attack patterns, and also it syncs the Google Maps camera movement with the LG rig by converting it into navigation commands. Therefore, it also supports map synchronization. The users can also play back historic cyber attacks and visualize them, and also orbit on any location that the user selects. Now behind me there is a mock-up on how the visualization would look on the LG rig. So let me walk you through it. So this is how the KMLs would look like on the LG rig. So these are the attack arcs I was talking about, and all the data related to the cyber attack happening is displayed on the most right side of the screen. I also have some of the UI UX mockups for the app, like this is the home screen, the map view, the analysis of the cyber attacks happening daily, and also this would be the settings screen. So the system will also support AI voice narration. So it will, for example, instead of raw numbers, it can say high volume of attacks detected in East Asia. So this will improve the accessibility and the storytelling part of the project. And now let's talk about how the AI is used in this project. So it is used in 2 key ways. First is the anomaly detection, where the AI will identify unusual spikes in attack activity using statistical methods. Second is the natural language summarization, where raw data is converted into human readable insights, with a future scope to integrate LLMs like Gemini for more advanced context. What makes this project unique is that it combines real-time data, geospatial visualization, immersive hardware like Liquid Galaxy. So most tools show cyber threats as tables or charts. This project transforms them into a spatial immersive experience where you can literally see attacks happening across the world in real time. Also, the system is designed to be modular, scalable, and compatible with the existing LG workflow. So it's not just a demo, it's something that can actually be used in SoC teams, education, and public demonstration. I believe I am a strong fit for this project because I already have hands-on experience with Liquid Galaxy, experience building Flutter-based system, and prior work with with data pipeline and visualization. So I won't just be starting from scratch, but building on a strong foundation. I'm really excited about the possibility to contribute to this amazing project that would, transform cyber threat data into from static dashboards into something more immersive and also in a real-time visualization on Liquid Galaxy. Thank you.
Hello, good morning. My name is Yasmina Ramadan. I'm 20 years old. I'm studying in Ilerna Lleida cross-platform application development. My proposal for the Google Summer of Code is titled City Historic Engine. This project focuses on developing an application dedicated to showcasing and exploring the historical heritage of any city, in my case, Lleida. The application will allow users to access historical and cultural information about various points of interest. All data and information will be stored locally using SQLite within the Flutter application, ensuring fast access and offline availability. Additionally, the system will be integrated with the Liquid Galaxy system, where selected data from the app will be visualized. For example, if a user selects a museum in Lleida, Liquid Galaxy will display the chosen museum along with its corresponding information. Furthermore, an AI-powered narration feature will be available, allowing the system to verbally describe the selected point of the interest. The initial development will be carried out using Flutter, and later, with the support of an AI agent, the same application will be adapted into web version. Thank you for listening. Goodbye.
Hello everyone, I'm Savana KV, a BTech Computer Science AIML student from Bangalore, India. Today, I'm presenting my GSoC 2026 proposal to the Liquid Galaxy Lab titled UNESCO World Heritage for Liquid Galaxy. My goal is to turn the Liquid Galaxy REC into an immersive UNESCO World Heritage Explorer where users fly across the globe, lands on a site like Taj Mahal or Wall of China, Petra, and experience their history in a cinematic educational way, not just a map but a journey. The data comes from the official UNESCO open data sets at data.unesco.org. Over thousands of heritage sites with names, GPS, coordinates, categories, and inscription years and descriptions. Every time you open the app, this is fetched fresh and processed into structured JSON inside Flutter, driving the site list, filters, KML generation, and narration content. So let me show you what I've built. This is the settings. You have to give the IP address, master node's IP address, SSH port, username, and password so that you can connect. You can see that it's connected. This is my home page, a live grid of heritage sites. Right now there are only 4, so there's no search option because there's only 4. We also have a search option and a filter option. The search bar, you can search any heritage site if you want, and the filter bar does 2 things. It filters by category and it filters by countries. Categories filters by cultural, natural, and mixed. Countries, all the countries will be mentioned, and you can filter it using that. Then when you select a site, the app dynamically generates the KML file and sends it to the Liquid Galaxy over SSH, and Google Earth flies to that exact location at the right camera angle and framing. On the right screen, you can see that there's an information panel displaying the cultural image, title, country, year of inscription, categories, and description. Here on the left side, you can see that there is a logo of Liquid Galaxy on the left top corner of the left screen. So there's also an start orbit option. when you start the orbit, the camera smoothly rotates around the monument, making the whole experience feels alive, cinematic, and right now voice narration isn't there yet, but it's coming during GSoC. What's coming is like AI. The biggest feature I'll be building is the AI-powered voice narration. The moment Google Earth lands on the site, it will narrate its cultural and historical significance, not just reading the raw description, but using AI to enrich and personalize it. This transforms the Liquid Galaxy into an intelligent guide cultural tool. I'll also improve image loading with caching and test thoroughly across regions worldwide. So let me tell you why this proposal is special. Because why you have to select this proposal, because this is the foundation I've already created and it's already running. The SSH, KML, orbit animation, data while UI, all are in working, and GSoC gives me the time to complete it and make it truly polished. I think I know Liquid Galaxy well because I've been working with Liquid Galaxy, doing all the prerequisite tasks, it's been months. So I think I can do my best, and I love this project because I don't know, it feels so unreal to travel all the places where you can't travel into your life, where you can do this on sitting right here, and you can do this and explore stuffs. So this is what excites me a lot. I'm Sahana KB from Bangalore, and I'd be truly honored to build this for Liquid Galaxy this summer. Thank you so much.
Hello everyone, my name is Yashwant Avasthi. I am from Lucknow, Uttar Pradesh. I am pursuing Integrated Master of Technology in Applied Geology from Indian Institute of Technology, Indian School of Mines, Dhanbad. And I am currently pursuing Institute Cyber App Development Division and currently mentoring my fellow students. The proposal I have submitted has titled Galactic Quest, a multi-screen RPG for Liquid Galaxy. The core goal of the project is to push the boundaries of what Liquid Galaxy system can do by building a fully immersive, multi-screen role-playing rendered across all rigs. Traditional gaming confines you to the single screen, although many apps have created which gives you experience of gaming on the rig like Galaxy Pac-Man. But they don't use multi-screen RPG. Also, they don't perform the combat situationships. So it will experience a 270-degree and across 5 screens simultaneously. Enemies flanking from the left screen and a mini-map on the far right screen, also the main character centered on the middle screen. This project has two core components, a rendering game client rendered on the Liquid Galaxy rig, and also a Flutter mobile app companion which acts as a control pad, or the inventory manager, quest log, and the player's controller. The Liquid Galaxy rig will render the live game world, environments, combat scenes, NPC dialogues, mini-maps, all synchronized across all screens in one state. The Flutter mobile app connects to the LG rig using the SSH networking using the Dart SS2 package. All transmitters as commands like movement, trackpad, interactions, attacks are transferred to the local Wi-Fi network using SSH packets, which then syncs to all screens using a 270-degree view. All players' progress, inventory, and save states are locally stored onto the Flutter's database Hive, which can later be modified onto the real time. A standout feature of the Galactic Quest is AI-powered NPC system. When the player interacts with the non-playable character on the rig, the far left screen displays the dialogue or the text extracted from the Gemini API, and the player can use a push-to-talk button to talk to the Liquid Galaxy rig. The rig will respond to the player in a context-aware and the real way using Gemini API, making the storytelling dialogue unique, making every NPC connection feel alive and unpredictable. The AI response is played back using text-to-speech narration, and this is all. So why should Galactic Quest be selected for GSoC this year? First of all, no one has built the multi-screen RPG for the Liquid Galaxy Previous LG projects have focused on data visualization and educational purposes more. So it opens a different new world for Liquid Galaxy, which demonstrate also that the Liquid Galaxy rig can also be used as a gaming platform. Second, the multi-screen game design is purposely built for using the all LG screens uniquely. Means we don't have to rely on the one screen or the three screen system, so we can use the five screen system simultaneously at the one time. Third, the Flutter Companion app act as a controller, which replaces the entire traditional gamepad entirely. It's a dynamic controller which uses inventory and the Flutter database as a system. All AI voice interface all under the one app. Fourth, I bring the hands-on experience as the Flutter developer and also the SSH networking and the Firebase. So I don't have any commitments this summer, so I can fully deploy and document the deliverables at the end of the GSoC. I am genuinely excited for Galactic Quest can bring to the Liquid Galaxy ecosystem, and I would love the opportunity to be with the Liquid Galaxy community this summer. Thank you for your time. I hope to see you on the GSoC other side.
Hi, my name is Kwon Kook. I'm from Chicago, United States. I study at Washington University in St. Louis, where I graduated with a degree in computer science. I now work as a software engineer focused on backend systems. My proposal is called Local AI with Gamma by Google. I submitted it on the GSoC 2026 platform. The goal is to build a local AI service that runs on a Raspberry Pi 5 inside the Liquid Galaxy network. Instead of calling a cloud API every time an LG app needs AI, this service runs locally on the same network as a rig, so it responds really fast. The service exposed 3 HTTP endpoints. The first is a KML creator. You send it location data. It generates a validated KML file that the rig can display directly on Google Earth. You can see here the mock of what that looks like on a 5-screen LG rig with generated KML plex mark on Eiffel Tower. The second is a content Q&A endpoint. You ask questions about the active scenes and it gives you a grounded answers pulled from local documents. The third is a voice endpoint. You send text, it returns playable audio. That audio can play through the rig speaker for narration. On the Flutter side, I designed a controller apps that interact with the service. You can see the app screens. First is a setup wizards that discover the local service network, a dashboard showing service health, the KML creators from where the operators fills in location parameters. You can also see the chat interface where a user can send question to the rig. And this is a controller to request voice narration on the rig. AI is central to all 3 endpoints. The KML creators use Gamma for structure generations, turning location parameter into valid XML. The Q&A endpoint use retrieval augmented generations, where Gamma only answers from context that was retrieved from a local document set. The voice use Piper, a neural TTS engine designed for edge devices. I also study the GSoC 2024 projects that tries to run Gamma locally on Liquid Galaxy. That project had to switch to Cloud Gemini because local inference were too slow. My proposal addresses that directly with newer hardware. The memory math and the hardware profile are fundamentally different at this time. I think this proposal should be chosen for 3 reasons. First, it solves real problems. Liquid Galaxy installations are in museums, classroom, public space where internet is not reliable. A local AI service that works offline, it genuinely works for these settings. Second, this is not a demo. It's a documented service with a stable API contracts published on GitHub with clear instructions. Any future LG app can call these endpoints without understanding the internals. The next contributor can pick up the work. Third, I have the right background for this. My daily works involves building backend system, fits the project. Also, I can commit 350 hours to the projects. Thank you very much for watching and for considering my proposals. I'm excited about this opportunity and about this project, and I hope I get a chance to work on it.
Hello everyone, I'm Sana KV, a BTech Computer Science AIML student from Bangalore, India. Today I'm going to present you my GSoC 2026 project proposal for Liquid Galaxy titled Bird Migration and Hotspot Visualizer. So basically every year billions of birds migrate across the entire planet. It's honestly one of the most incredible things that happens in the nature. So, but if you actually go and look at the data, there's only tables, flat maps, numbers. It doesn't feel like anything. So that's the problem I want to solve right now. I'm building an app that takes the data and puts into the Liquid Galaxy, showing a live 3D globe. So instead of like staring at the spreadsheet, you're actually looking at the Liquid Galaxy screens, and you see birds migrating from one place to another across the continents live. So the data comes from the eBird API. It has over billion real bird sightings submitted by the bird watchers all over the world. So the data is massive and it's real and it's live. So the Flutter application I'm building lets you pick a region, say the eastern US, the data range. It fetches the data, processes it, generates the KML, pushes them like KML files to the Liquid Galaxy over SSH, and the globe lights up glowing dots showing where the birds are, and animated lines tracking the migration routes across the maps. Now the part I'm most excited about is AI narration. So instead of just watching lines move on the globe, there's with no context there's a voice that actually explains what you're seeing, like, and this is not a pre-recorded script or something. It reads directly from the live data. So if right now, like, there are 18,000 trees shallows moving through the eastern US, the voice narration sees this. It says which species, which hotspot are most active, why certain location matters, and so on. So I'm using the Flutter TTS package for this voice narration, and the narration is built fresh every time for from whatever the API, like from just returned. So my demo, you can see that there's the Flutter app, but that's not exactly what I'm going to do in the summer. This is just the demo. You can see that here's the migration flyways, and if you click on something and fly to that, this screen flies over and it lands over there. And I'm planning to make it look something like this with the arrow lines, but the KMLs are not ready yet. So also Uh, there are bird hotspots. You can fly to a place. Something like this. It looks something like this. So this is what I'm gonna plan, but the KMLs are not working right now. This is my like this is what my imagination is like. The KML should look like this on the real liquid galaxy thing, and I just want this lines, all the things, to look the same in the liquid galaxy. So I'm still working on this. I will be done. So I'm really excited to see how it's gonna turn. All the AI narration, like all the voice narration and stuff. So I'm really excited about this. Thank you so much.
Hi, my name is Abhay Garunavar and I am Liquid Galaxy GSoC 2026 aspirant. I am currently studying Bachelor in Technology in Computer Science, specialization in the Artificial Intelligence and Machine Learning. Basically, I am studying in Medavishkil's University, and my project name is Cyber Attack Visualization, made by Siddharth Mudgil mentor. So let's move into the mockups first. So this is how the splash screen of the Flutter app basically looks like. And this is the SSH connection screen. So basically, as all the Liquid Galaxy app has the IP address, port, SSH username and SSH password input, we also have followed the same rule. Moving on, this is how the live thread dashboard in the Flutter app looks like. Basically, we have two sections. One is the live and the history section. So live tells the live cyber attack threats in the Liquid Galaxy rig. Around 6 cyber attacks have been installed in the Flutter app. The DDoS, malware, ransom, SQL injection, botnet, and the brute. A small mini live map preview is also displayed in the Flutter app itself. So moving on in the history section, basically I have designed two filters. One is the month filter and the other is the location filter, so that you can get to know about the particular location which has the most number of cyber attacks and everything. So the basic interface which you can see in all the Liquid Galaxy apps, the clear KML, the orbit at my location option. The menu takes you basically back to the SSH input interface, and the info basically tells about the all cyber attacks, the 6 cyber attacks that I just told, and the statistic basically tells the change in cyber attacks in the past few years. Basically, it is displayed using a graph which I will show next, and the countries with the most number of cyber attacks and how it has influenced worldwide will be shown in the countries section. So this is another splash screen, but for the Liquid Galaxy rig. Basically, it stays around for around 5 to 6 seconds, and then it moves on to the main part, which is the cyber attack interface. Basically, around 6 cyber attacks, and 6 different colors have been assigned to each one of them. The red, green, and purple, dark blue, yellow, and light blue basically. By hovering around the location, you get to know about the volume of the cyber attack and many other important information. Red, orange, and yellow determines the intensity of the cyber attack basically. These all are basically the mockups of each and every cyber attack that I installed. So this is how the countries with the most number of cyber attacks interface looks like. And the main part is the Flutter TTS AI voice basically. So when a live threat is detected, the Flutter app announces the location and tells that the cyber attack, basically which cyber attack. So if the ransom attack is happened, so the Flutter TTS says that a ransom attack in the New Delhi, India is located basically. So moving on, this is how the statistics mockup looks like. So this was all about the mockups, and when it comes to the AI usage, there is a minimal AI usage used in this. I have used basically the Figma to design everything, and just for the color palette and the background of the images, I have used the Gemini AI. And why my proposal stands out from the others is that I have a prior contribution in the NVIDIA R2 Studio, and in the Google DeepMind OpenSPL organization, which you can see in the proposal itself. And also I have also built a prototype that you can see in the proposal. I have pasted the link in it. And I have worked on other neural weather models such as the MLLAM AI weather assistant and many more. So these are the main reasons why my proposal would be better than the others. So that's it. My name is Abhay Gauranavar. I'm a GSoC 2026 aspirant. Thank you.
Hello everyone from the Liquid Galaxy team and community. My name is Bhumi Shivahare and I am recording this from Dehradun, India. I'm currently a final year BTech CSE student at GLU University with a strong focus on building data-driven and scalable systems. I'm also working as a software development engineering intern where I am gaining hands-on experience in building real-world applications. Today, I'll be presenting and defending my proposal, EcoGrid Intelligence, an AI-driven climate resilience for global energy infrastructure on Liquid Galaxy. The goal of this project is to bridge a critical gap between climate intelligence and energy infrastructure. Today, we have access to massive amount of climate data and detailed information about global power systems, but they exist in isolated silos without a unified way to understand their combined impact. What's missing is a system that can connect these data sets and answer a critical questions. Which energy infrastructures are at risk? Why are they at risk? And how does that risk evolve over time? EcoGrid Intelligence is designed to solve exactly this by creating a unified AI-driven geospatial system that analyzes climate impact on infrastructure in real time and makes that insight interactive through Liquid Galaxy. Now, what you're seeing here is the core interaction layer of the system. This map represents global energy infrastructure where each marker corresponds to a power plant. The system integrates real-time climate data from the OpenMeteor API, including temperature, precipitation, and wind anomalies, with infrastructure data from the global power plant database. This combined data is processed through a model I've defined called the Climate Vulnerability Score, or CVS. Each plant is dynamically evaluated based on environmental stress, which is why these markers are color-coded on vulnerability levels. So instead of just looking at locations, we are actually understanding which infrastructure is at risk and up to what extent. Now, when this analysis is pushed to Liquid Galaxy, this is how it is visualized. You can see climate anomaly heat maps layered across the globe along with the infrastructure markers. This creates an immersive multi-screen spatial experience where users can instantly identify high-risk regions at a global scale. The transition from the application to Liquid Galaxy turns this from a data analysis system into an interactive visual exploration of climate impact. Now, what makes this system truly powerful is the AI orchestration layer. I'm using Google Gemini as an agentic layer that manages workflow end to end. Instead of manually controlling each step, the AI autonomously identifies relevant climate data, retrieves the required data, interprets the CVS, and structures the output for visualization. It also generates contextual highlights exploring why a specific infrastructure is at risk. Additionally, the AI enhances the Liquid Galaxy experience by guiding camera movement, automatically navigating toward high-risk regions, and creating a more interactive, story-driven exploration. So the system doesn't just visualize. What makes this proposal truly stand out is how it brings together real-time climate data, AI-driven intelligence, and immersive geospatial visualization into one unified system. Most solution either focuses on analysis or visualization. This system does both and connects them in a way that makes the insights interactive and easy to understand as well. It transforms Liquid Galaxy from a visualization platform into a system for analysis, exploration, and decision making. Beyond that, I have focused on building the system on a strong and well-structured foundation, from the data pipeline and model to efficient KML generation, ensuring that the final system is robust, scalable, and practical to use. I believe that this project aligns strongly with the vision of Liquid Galaxy and has meaningful real-world impact in areas like climate resilience and energy planning. Thank you for your time. I'd be really excited to contribute this to the Liquid Galaxy platform. Thank you.
Hello everyone, my name is Dipen Nandwani and I am from Delhi. Currently I am pursuing BTech in Artificial Intelligence and Machine Learning from Guru Gobind Singh Indraprastha University, which is in New Delhi. Along with that, I am also pursuing BS in Data Science and Applications from Indian Institute of Technology, Madras. The topic of my project is Flutter Air Mashup, Elevating Airspace Visualization. In this project, we will represent real-time flight data such as airspace, airports, flight routes, etc. to the Liquid Galaxy rig with the help of 3D colored KMLs. A Flutter-based application will connect to the Liquid Galaxy rig with the help of SSH connection, and then it will send 3D colored KMLs to the Liquid Galaxy rig to represent the flight data. The flight data will be extracted from websites such as opensky.org, which would provide us with OpenSky API for real-time flight data such as latitudes, longitudes, velocity of the aircrafts, airports, etc., with which we would convert it into KML structured format for sending 3D colored KMLs to the Liquid Galaxy rig. Aircraft models. This feature would show the aircraft manufacturers' production plants in Google Earth. The user will be taken to the locations where the production plants of aircraft manufacturers are situated, and it would be shown with the help of KMLs and also details on the rightmost screen of Liquid Galaxy. The next feature is live air traffic. In this feature, the user will be able to see 3D aircraft flying across Google Earth, in which it would give a great visualization experience. The next thing would be flight routes. In flight routes, the user will be able to see multiple colored lines from one place to another in 3D to represent multiple flight routes across Google Earth. The next thing which is there is Airspace. Airspace will feature data such as OLS, which is Object Limited Surfaces, and Aeronautical Information Services, AIS. In this feature, the users will be able to see minute details which are important for aerospace industry. The next thing is Project Wind. Project Wind is a service where parcels are delivered from one place to another around the world with the help of drones and other types of aircraft. AI-based text-to-speech. With the help of this feature, complex flight data can be converted to simpler language so that people can understand flight data in a better way. Another great feature is orbit mode. With the help of this feature, the user can orbit at any location on Google Earth inside the Liquid Galaxy rig, in which the camera will move 360 degrees around that location to give a great experience to the users. Now, the special thing about my project is that it is a combination of real-time flight data, storytelling, along with AI-based text-to-speech and audio. Now, the special feature that we're going to talk about is the launch demo button. With the press of a button, the user will be taken on a journey to airports, airspace data, flight routes. Along with that, it will also narrate a great story with the help of AI-based text-to-speech using the Flutter TTS package. With the help of this, the user will be able to understand flights in a better way. Now, the reason to select me are that I've been contributing to the Liquid Galaxy project for a long time now. So I understand the system architecture with which Liquid Galaxy is working. And also I've reviewed some of the repositories of Liquid Galaxy, and I'm also thinking of many ideas of how can we improve them. Another thing is that I've been working on this great project in which we can transform real-time flight data to the Liquid Galaxy rig, in which the KMLs would be presented on the Liquid Galaxy rig to give an immersive experience to the entire community of Liquid Galaxy and also to the people around the world. Thank you so much.
Hi, my name is Nanya Boyana Srujan Yadav. I am from Andhra Pradesh, India. I am currently pursuing BTech second year at Chaitanya DM University, Hyderabad. The title of my proposal is AI Educational Tourist Explorer. The Liquid Galaxy currently shows the locations visually, but not provided the guided information of those locations. My project solves that by creating an combined visualization and structured information in the narration format, which gives the best guiding explore of locations the best. The data presented on the liquid galaxy is the 3D view of the selected location with smooth camera movements like fly to the location and orbit, and we provided the contextual information in the rig about the selected location. Now we see user flow in our project. Here in the screen we have the mock-up screens of the app. The middle screen, which is highlighted, is the main screen where the user gives his input as a location. The location was sent to an API request to get the response. When the response is received in our app site, and the response was processed and converted into KML, which is responsible for visual appealing in the liquid galaxy. Here in the main page we have a floating container which has a button called start. When the user clicks that button, the KML file was sent to liquid galaxy through an SSH. The KML was helpful for showing visuals in the liquid galaxy. In the same side, the narration of the content generated about the location was playing in the app in a synchronized manner. This is the total flow of user in my project. AI is used to generate structured information about the selected locations, such as history, latitude, longitude, and other information. The system sends predefined prompts to ensure that the response follows a fixed JSON format. This output is validated before being used in the application to avoid errors. If the response is not valid, the system uses predefined fallbacks data to maintain readability. The project transforms a liquid galaxy from a simple visualization into a guided learning experience platform. It combines the AI generated content with 3D visualization to help users understand places, not only see them, and the liquid galaxy more useful for the education purpose and public demonstrations also. I have already worked with the liquid galaxy system by setting up a virtual rig and building a Flutter app to control the rig from the app through an SSH. I have strong experience in Flutter KML based visualization and also worked with AI integrations in the app side. And this hands-on experience pushing me forward to contribute this project effectively. Thank you for your opportunity.
Hello everyone, my name is Tanishq Sharma and I am from Ghaziabad, India. I am a third year Electronics and Communication Engineering student at Punjab Engineering College in Chandigarh in India. Today I am presenting my Google Summer of Code 2026 proposal Liquid Wings for Liquid Galaxy Organization for Project Defense Day. The idea is simple. Imagine sitting in front of a liquid galaxy rig, 5 screens arranged in a curve around you. You are inside a fighter jet cockpit. The world spreads seamlessly across all 5 screens. Terrain below, sky above, and in multiplayer mode, another pilot somewhere out there trying to get behind you. Your phone is the controller. You hold it horizontally, tilt it back to bank, pull back to climb, just like a real flight stick. The gyroscope reads your wrist movements as pitch and roll. Throttle is a slider on screen, and in dogfight mode, a fire button also appears. The entire system is driven by a single Node.js server running on the rig's master machine. It handles everything: flight physics, game state, weather missions, and multiplayer simultaneously. Every screen connects over WebSocket and receives the same state broadcast 60 times per second. Each browser renders the full 3D scene using Babylon.js but rotates the camera by a fixed angular offset, so together they form one seamless panoramic view. The Flutter controller app connects to the same server over local Wi-Fi the network rig already uses. The project has two main modes. Mission mode includes three types: checkpoint runs, where you fly through rings in sequence against the clock; a canyon mode, where you navigate tight terrain corridors without touching the walls; and enemy intercept, where you hunt an AI controlled aircraft before it reaches its destination. The second mode is 1v1 dogfight. Two Liquid Galaxy rigs, two players, and one shared server, each pilot seeing only their own perspective across their five screens. For AI, I am integrating an AI voiceover system that generates immersive audio callouts, mission briefings, checkpoint confirmations, hit alerts, and success or failure announcements, all triggered automatically by the server state changes and delivered to all screens in real time. What makes Liquid Wings stand out is that it treats the Liquid Galaxy rig not as a display tool but as a gaming platform. The panoramic setup is perfectly suited for an immersive cockpit where you don't need VR goggles when you have five screens wrapping around your field of vision. Every technical decision is made with the rig in mind. Physics on the server means all screens stay perfectly in sync. Web-based rendering means the system deploys on any rig without custom software. The phone controller makes it instantly accessible to anyone. So this is all for my proposal, Liquid Wings. Thank you.
Hello everyone, I'm Raksha. I'm an undergraduate student pursuing BTech in computer science and specialization in artificial intelligence and machine learning. I'm from Bangalore, India. I like coding and interested in building the applications, especially when they work with the huge data sets or the databases. So when I came across the Liquid Galaxy, I found it very much interesting because it represents the data, huge data, much more in a visual and interactive way compared to the normal applications, and that is what made me to work on this project today. So the name of my proposal is the Global Language Distribution Map. The main idea of this project is to take the language data, which is usually hard to read and understand, and turn this into something that users can see and explore directly on the map. So instead of going through the huge tables or the documents, users can move across the region and clearly see where languages are spoken, how they are spread, and how they are connected to each other. Along with that, this project also focuses on showing the language diversity, the endangered languages, so that the users can understand not just the distribution but also the importance and condition of the different languages. So the goal of this project is to make this information simple, visual and interactive so that anyone can explore and understand it easily. So for this project, I use three main data sources. From Ethnologue, we get the language names and the number of speakers and the regions where they are spoken. From Glottolog, we get the language classification and the geographic coordinates. From UNESCO Atlas, we get the endangerment status of the different languages. So this data is combined and then it is matched with the Geo Boundaries API, which provides the region boundaries in the GeoJSON format. Then this GeoJSON data is converted into KML files, which are used in Google Earth in Liquid Galaxy to display different things like the language markers, the colored regions and the detailed information panels. So this is the app for this particular project. In the home screen, the users can explore what they want to learn, and in the map screen, the users can move around the map and explore the languages. The family screens have the list of the different language families, and in the guided tours, the users get the guided tours while exploring the language distribution. And in the settings screen, we can connect this app with the Liquid Galaxy rig, and we have a view detail screen where it gives the complete information about the selected language, and we have an option of the text to speech as well. So this is about the app of this project. Then we'll get into the mockup. So this is the Liquid Galaxy mockup. The regions are displayed using the 3D colored polygons, where each color represents the language spoken in that area. So when I just select any region, a balloon appears on the screen showing the language name, the number of speakers and the language family. And on the right screen we have a balloon showing a complete information of all the languages that are marked on the Google Earth. So this is and also users can move around the Earth to explore different languages spoken in different areas. This also works with the guided tour features as well, which allows the user to explore the regions automatically. And also this helps in comparing the areas, understanding the language distribution and seeing the patterns visually. So this project also uses the AI to make exploration easier. The one is the AI chatbot, allows user to ask the simple questions and get the direct answers. Then we have the AI voice assistant that reads out the details like the language name, the number of speakers and the location. So this proposal feels special to me because of the idea behind it. So when I looked at the language data, I felt that we have got a lot of information already existed in the databases, but we don't really see it or experience it clearly. So this project focuses on turning that idea into something that people can actually explore and understand visually. So we know that the languages are not just the data, they represent the culture, the identity, the history and all. So instead of just showing the information, this project tries to show how languages are existing, how do they spread and how do they connect in the real world. So the goal is to make everything simple, clearer and meaningfully so that anyone can explore it easily. Thank you for watching my presentation. I'm really interested in building this project and making the language data more visual, interactive and easy to explore using the Liquid Galaxy.
Hi Liquid Galaxy team, I'm Samatma Evaradwaj, a second year undergrad student pursuing my BTech in Computer Science and Engineering at PES University in Bangalore, India. I have past experiences of working on projects using Java, Python, C, C++, Flutter and Munstack, and I'm particularly interested in the field of cybersecurity, artificial intelligence and UI or UX design. Now coming to the idea of my proposal, let me start with a simple question. What if you could actually see cyber attacks happening across the world in real time, not just logs, but where they start, how they move, how they spread, where they hit, all of that. For example, you could see why you need to figure out why do some regions experience repeated attacks, or why does some types of certain attacks spread globally within seconds. The answer to this lies in patterns which we need to recognize extremely deeply. And on a simple seeing of raw logs, we won't be able to figure it out. So we usually analyze this through dashboards, logs, raw logs, and that makes it very difficult to understand how everything is actually connected. So what if we could actually explore cyber threats like a live global system instead of static data? And that's exactly what my project does. My proposal is titled Cyber Attack Explorer, Immersive Visualization of Global Cyber Threats using Liquid Galaxy. What you see here is not just visualization, but it's an entire control system for global cyber activity. Let's say the user selects DDoS attack. Within a single interaction, the system navigates to affected region. It animates the traffic flows across the globe using colored arc lines. So instead of reading about where DDoS attacks are happening, you can actually see how it propagates in real time. Or imagine sorting out by region and selecting to see the regional heat map of Europe. So you get to see a threat heat map depicting regions at higher risk in red color, whereas regions with lower risk in green color, and also a dashboard depicting details of the attack, types of attack and color legend to the map, so on the rightmost screen. And then this is the arc lines depicting attacks on Japan, and this is the heat map for Japan. And then this is the heat map depicting attack intensity across different regions of India. And then this is the arc lines depicting cyber attacks happening in the city of Paris. And then this depicts arc lines depicting cyber attacks happening in Indian city of New Delhi. So all of this is powered by real world datasets from cyber threat intelligence platform like Kaspersky, Cybermap, Digital Attack Map, and other structured open source datasets. So it is based on real cybersecurity data. Now coming to how this actually works, think of it as two systems working together, a Flutter-based mobile application where the user interacts and the Liquid Galaxy where everything comes to life. When the user selects something, the data is processed, structured and converted into KML layers and then sent to Liquid Galaxy, and then a guided visualization is triggered across multiple screens. Also immersive storytelling using Gemini API and DeepGram is also triggered, and everything stays synchronized with the Google Maps in the mobile interface. Now, coming to the AI used in this program, this is where things get more interesting. AI is used to generate real-time explanation using Gemini. It is used to provide voice narration using DeepGram, and it helps translating complex activity into simple structured stories. So instead of just visuals and logs, users get an analytical experience. Now, what makes it special? This system allows user to see how different attack types behave, how how different patterns evolve over time, how different attacks originate and spread globally. So it answers to the question of how attacks are happening. So the reason I find my proposal to be special is it transforms Liquid Galaxy into more than a visualization system. It becomes a platform for cybersecurity exploration, education, and awareness with immersive data storytelling. So, um, and instead of just showing isolated data or focuses on logs or dashboards, it focuses on complete visualization like a control room with immersive storytelling. I am deeply interested in this project because it combines real-world cyber security data with strong technical implementation and intuitive user experience, fully utilizing the capabilities of Liquid Galaxy. And more importantly, it helps understand importance of cyber threats as not just isolated incidents, but a connected global phenomena. If selected, I have a clear and a realistic timeline to implement my proposal, and I'm also extremely eager to contribute to Liquid Galaxy's great community and learn from amazing experienced mentors. Thank you very much for considering my proposal.
Hello everyone, my name is Aryan Sarma and I am from Kanpur, Uttar Pradesh, India. Currently, I am a second year integrated master's student in applied geophysics at IIT Dhanbad, Jharkhand, India. Today, I am excited to present my GSoC proposal idea titled Luna Explorer for Liquid Galaxy. Luna Explorer is Flutter-based mobile application that turns the Liquid Galaxy into an interactive geological observatory of the moon. The idea is to transform complex lunar scientific data into an engaging, impressive visualization. The application will be built around the real scientific data from the institutions like NASA, USGS, ISRO. In app, user can explore craters, mineral and rock composition, dark maria, highlands, and crustal thickness of the moon surface. All features are integrated with AI voice explaining the geological features, which increase the engagement and understanding of the user. The app also includes a section of mission which visually represent landing site, EVA traversal path, and geological discoveries of the Apollo and Chandrayaan mission. All the data is processed and is structured into the KML files which are sent to the Liquid Galaxy via SSH using Dart SSH2 Flutter package. A separate section would be for AI voice integrated tours such as important crater tour, polar regions, and Apollo landing sites, and their geological significance in shaping the moon. The app feature of Linux AI, it is built-in assistant powered by Gemini API that act as moon expert, and user can interact with it to clear any terminology related doubts or any other doubt by voice or text. Every tours, every exploration feature, every mission is narrated by an AI voice guidance using Flutter TTS package, making exploration feel like a live documentary. And there is an interactive lunar geological quiz where answering the question led to fly the LG to that location in the moon, with AI explaining the answer. Near side and far side of the moon, their geological exploration is supported by real-time lunar phase data from Moon API to simulate lunar illumination on the liquid galaxy system. Additionally, I have also included a mobile home screen widget. This allows user to quickly access basic control of the Liquid Galaxy rig directly from the phone home screen without even opening the full application. So it makes the interaction faster and more convenient. Overall, this application is the combination of scientific data, interactive visualization, and AI powered guidance, all brought together to create an impressive lunar exploration on Liquid Galaxy. Through this app, user can explore whole moon and understand why the moon looks the way it is. Then why this proposal is special and why does it have to be chosen for this year. As my proposal is a strong combination of scientific accuracy, interactivity, AI powered guidance, this is not just a visualization tool but an education exploration system. Also, my background in geophysics helps me to understand the geological significance of the data, allowing me to present it in more meaningful and structured way. Another important point is that currently there is no application that focus specifically on the moon in such depth. For the past years, liquid galaxy projects are more focused on Earth visualization, but moon visualization and its feature exploration is untouched till now. This makes Luna Explorer a standout proposal for this 2026 year, as it's only focus on moon exploration. In last, I truly believe that Luna Explorer will make LG a portal to moon exploration. Thank you for your time and consideration.
Hi everyone, and hi Liquid Galaxy team. I'm Karthik, and I'm currently studying in second year, doing BTech CSE from Indraprasth Engineering College. Today I'm going to defend my proposal for GSoC 2026. It is titled as Local AI with Google Gemma on Raspberry Pi 5. Uh, for this proposal, my main goal is to bring Gen AI powers directly to the Liquid Galaxy rigs along with offline capabilities. It's going to make it a complete private because it's not going to be relying on the cloud. The core idea is very simple, as you can see on my screen. Uh, I've already created a UI UX mockup for our controller app, and on the second screen we have the architecture of our whole system that we're going to be creating in this proposal. The core idea is very simple. It is to stop relying on the cloud. As you can see on my screen, the second screen, I have made a simple architecture for this project. So we're gonna be using Raspberry Pi 5 as our local AI server. So one of the question is how will the data will be handled. So the Flutter, our controller app, the basically the one that a user is going to use to give commands to the rig and to create like KMLs and to talk to the AI. So basically this controller app is the main connection between the AI servers and our rig. uh, for example, let's say the user asked, show me Eiffel Tower or show me Tokyo Tower. So what's going to happen is the backend will give this specific query to the our AI server, like AI on the local server. It's going to be interpreted and processed, and the Gemma, the our AI model, is going to process it and generate a relevant response. For example, in this case, it is supposed to generate a dynamic KML. It will generate a dynamic KML and it will send both to our phone and to the rig. So at the same time, we're gonna be seeing some basic information about Tokyo Tower or Eiffel Tower, the which one whichever the user has selected, and at the same time it's going to be shown on our Liquid Galaxy rig, the panoramic view that we are going to be using the 5 screen. So for for AI model, we are going to be focusing on Google's Gemma 2 billion parameter model. Because it's a 2 billion parameter model, it's the perfect fit for our local AI server. And But still, we're going to be implementing 4-bit quantization. So basically, it's going to be reducing. It's going to be drastically reducing the loads on the Raspberry Pi 5. We're gonna be using AI, Gen AI for three main things. That is dynamic KML generation. Second one is contextual content for factual and historical information about the landmark that the user has searched for. The third thing is we're gonna be implementing local text to speech using Raspberry Pi AI kit. So it's basically we're gonna be using that kit for hardware acceleration that keeps the rig from lagging when the AI is generating a response or creating a KML file. Why is this proposal very special? Because it solves one of the biggest hurdles of Liquid Galaxy, that is cloud dependency and subscription cost for Gen AI powers. By introducing local AI servers on Raspberry Pi 5, we are solving both of these issues. That makes our rig self-contained, kind of self-contained, because this model is not very powerful, but since we have some hardware limitations on Raspberry Pi 5, so this model is perfect for Raspberry Pi 5. And I've also built some API endpoint schema for this project to be realistic, and alongside a great UI UX for our Flutter controller app. And I have the technical skills to see through this project till the end. Thank you very much for your time. Thank you very much.
Hello everyone, I'm Raksha. I'm currently doing my BTech degree in computer science with a focus on artificial intelligence and machine learning. I'm from Bangalore, India. I've always been interested in building the things with the data. So when I came across the Liquid Galaxy, I really liked how it lets you to see and explore the data on the Google Earth. So the project I'm presenting here is the Biodiversity Explorer for the Liquid Galaxy. So this is the result of my interest on the data visualization. So the idea behind this project is simple. There is a lot of biodiversity data available, but most of it is hard to understand because of it's in tables or the numbers. So this project turns that basic data into something visual and interactive, where you can see where the species exist, identify biodiversity hotspots, and understand how things change over time. So instead of just reading the data, you just look at the Google Earth and immediately understand it. So for this project, the data comes from the GBIF for the land species, and the OBIS for the marine species, and the UNESCO and IUCN for the endangered species. Based on what the user searches or the filters, the app fetches and shows this data on the globe. So the main features of this project is the interactive map, the search, species search and the filtration, then the heat map, then the endangered species view, guided tours, the timeline slider. So the guided tours, instead of just manually exploring everything, the system takes you through the important regions automatically. So the camera moves smoothly, pauses at key locations and shows what's important. So it feels like more like a story, not just a navigation. Then comes the timeline slider. So this lets you to move across the years and see how species distribution changes over time. So instead of comparing data manually, you can actually watch the change happening. So this is the app for this particular project. Here we have 3 different modes. The first one is the story mode for the guided tours. Then is the insight mode where the app highlights the patterns. Then is the discovery mode for where the users explore it freely. Then we have the hotspot region. Then we have the endangered species. Then the tour screen, which gives you the guided tours. And we have the settings screen as well for connecting this application with the Liquid Galaxy rig through the master's IP address and the username and the password. So this is about the app. Now let me show you a small mock-up of how this works. So here I have visualized the tiger observation spots across the India using 3D KML. So each of these markers represents a location. Since it is in 3D, it gives the more immersive view when you are moving around the screen. So if I select any spot in this, yeah, it opens a detailed panel with the information about the species and the specific region. So users can navigate freely, zoom in and move across the areas and compare the different regions side by side. So overall it makes the data feel more interactive and easier to understand. So what makes this project special is it's not just about showing the biodiversity data on a globe, it's more about how the user experiences the data. You can actually explore it in a natural way. You can see the patterns at the global level, zoom in and look at the details, or just follow the guided tours. So it works for both casual exploration and also for the deeper understanding. So the system is designed to be flexible and scalable. So in the future, if we want to add any new data sources or any new features, we do not have to rebuild everything again. And I really enjoy working on these things where the data and the visuals come together. I focus on not just building the features but also on how smooth the experience feels, how the interaction works, and how easy it is for user to understand the data. Uh, so overall, this project is not just about visualizing the data, it's about making it easy to explore and actually useful. This was the presentation. Thank you everyone for watching.
Hello, my name is Mahmoud Mohammed. I'm from Egypt. I'm final year student at Faculty of Computer and Information Science in Shams University. My proposal is about Ubuntu LTS support for Liquid Galaxy. The goal is to make Liquid Galaxy run smoothly and reliably on Ubuntu 24.04, which is the latest long-time support release. Why I choose this project idea specifically? It's really simple. When I started working on Liquid Galaxy prerequisite task 1, I already had another distro called Kali Linux and another newer versions of Ubuntu. And I found out that Liquid Galaxy only ran on Ubuntu 16.04.7, and if you try to install it to the newer versions of Ubuntu, it will not be installed correctly because it will have compatibility issues. So it reminds me to one of the Unix philosophy, which is always, it choose portability over efficiency. Like, make your system or make your software adapted to the environment and not limited to specific release or to specific distro or something. And now most people use the latest release of Ubuntu because it has updated packages, better support, better performance, and one of the important thing is security patches. If the system has a vulnerability, Ubuntu will release a patch that will fix this vulnerability. On the other hand, the older versions like Ubuntu 16.04.7, it's already lost its support from Ubuntu, like from 4 or 5 years ago. So assume if Ubuntu 16.04.7 someone discovered a vulnerability, Ubuntu will not release a patch that will fix it. So it makes the system less secure and harder to maintain. And from technical perspective, how I will approach this problem? I think I will need to understand Liquid Galaxy architecture in details, like how files are organized, how components are calling and communicating with each other, and how dependencies and packages the system relies on. It's not a simple system migration. Liquid Galaxy is a big system that contains OS level configurations, scripts, package and dependencies, services, and a lot of things. So you need to be careful and to know all of that in details. And then I will analyze the installation script, and after understanding everything, I will make it compatible with Ubuntu 24.04, and I will update the installation script and make the system run smoothly. And one of my another goal is to make the installation script smart enough to identify the distro type, like it's Debian or it's Red Hat, and to detect the release of the user machine, like it's older release or it's a newer release, and depending on all of that, it will follow the setup instructions for each release. Like for newer versions, it will run a setup instruction, and for older version like 16.04, it will run that. And I hope it will not be limited to Ubuntu 24.04 or Debian distros only. And why this project is impressive? Because it focuses on the core and on the foundation of the Liquid Galaxy. It will not add new features, but it will improve efficiency, it will improve usability, portability, and the important thing, long-time support. And regarding using AI, I think it will assist me in debugging, in logging analysis, find deprecated packages and their updated packages beside my search, of course. And why I see myself a good fit for that, I enjoy Linux systems. I enjoy knowing and understanding how systems works internally together and behind the hood. And that's it. Thanks.
So, hi Liquid Galaxy, this is Omar Sameh. I am a third year GSoC University student in Egypt. My background is about I did many projects. Some of my projects are like audio player, e-commerce, Amazon clone app. But my most related applications that I did with using Flutter related to my proposal or my topic that I apply for is news app and weather app. So my proposal this year will be in the topic which is AI educational touristic explorer. The goal of this project, of course, is to make the UNESCO data of the heritage sites more of like attractive, interactive, and visually appealing. So I plan to do this by fetching the UNESCO data through an API and like visually presented using the 3D place marks and colored polygon and the fly to camera placing and the Liquid Galaxy rig. So I think this is for the goals and also explain the static and the brief explanation of the heritage sites that UNESCO returns as a data with a AI audio explanation using Google Gemini. So why do I think this project matters? I think this project matters because it has a really great potential, especially here in Egypt. We have this Grand Egyptian Museum. The Grand Egyptian Museum, it has virtual reality, and tourists loved it so much because it is an immersive experience on how culture or the ancient Egyptians' culture was. So it showed this in an immersive way. So I think it's a great idea. Okay, so why I think I am the suitable candidate for this project. I think that it is mainly because of my alignment, my background and my culture alignment with the project. I think it is mainly because of this. And the other things is that I don't just code. It's not just about technical thing. I think there is more to technicalities. I think it is about the identity, how to make the app feel premium, not just look premium. It just feels premium. So it is. It's about a whole identity behind it, and especially that I won a hackathon in education track with the Google developer groups and in Delta. I won the eighth place from 122 teams in education track. So I think I have much experience in this field.
Everyone, my name is Harsh and I am a pre-final year student at VIT Pune. My hobby is sim racing, and other than that, I also enjoy learning about how things work. For example, I spent a few hours just reading about the history of QR codes and how they work. So, I have worked on several projects throughout my course, and current one being a machine learning based project which I am making for a company based in Hamburg, Germany. And I have also published multiple research papers in the field of IoT, cybersecurity, and AI. So, the title of my project is Local AI with Gemma by Google. And this project aims to create an agentic AI server that will live on the local area network of the Liquid Galaxy rig, and it will act as a personal assistant to anyone who wants to use Liquid Galaxy. It can be mentors or contributors who have a bit of technical expertise, or people who want to learn about Liquid Galaxy and how it works, or any kind of person who has zero technical knowledge in creating Flutter apps or web apps, or they don't know how you can use KML to visualize things on Liquid Galaxy. Even they can use this. The user interface would be very easy and user friendly. User experience is a better word. So you can just say it using your voice. You can type in natural language, and the AI server will also respond in its own voice. So in these ways, you can interact with it. There will be also additional support for third-party applications such as Telegram, WhatsApp, Slack, Discord, etc. You can put your message in there, or you can send a voice note, and the AI server will respond in the form of an action. So how it works is that we will be leveraging current agentic AI protocols that understand the user intent and create dynamic KMLs. An example of this would be me typing out, please tell me the history of Berlin Wall, and it will create a visualization and give me a tour on the Liquid Galaxy rig about the history of Berlin Wall. So it creates KMLs dynamically at runtime. Other instance would be using it for, let's say, Olympics. So I'll ask, please tell me what is the schedule of the event. It will perform a web search and read news articles, maybe using RSS feeds, and it will create a tour of, let's say, day wise event. Like today there is an event at this place at this stadium, and it will give me an orbit of that stadium. Then it will proceed to some other place. So these are a few use cases. This project will also help you create Flutter and web applications for your own personal use cases. And there will be multiple sources of data in this project, ranging from OpenSky Map, SatNav, and RSS feeds, etc., to performing web search also. So it will perform queries on the internet for things like getting event schedule for the Olympics, like I mentioned. In this case, your imagination is literally the limit of what this system can do. It is so powerful, and that's what makes it special. Because Jensen Huang, who is CEO of Nvidia, also recently stated in the Lex Friedman podcast that these agentic protocols are literally the iPhone movement of AI agents, and everybody is now rushing to adopt and learn these things and use them for so many kind of tasks. So this project will introduce agentic AI and these agentic protocols for the Liquid Galaxy ecosystem. So I think it would be a great project to be selected, and it would be great to be able to work on this project. Thank you so much.
Hello everyone, I'm Soumya Bhattacharya. I'm from Kolkata, India, and I'm pursuing BTech in Computer Science Engineering from National Institute of Technology, Durgapur. And I will be presenting my proposal for the Liquid Galaxy project titled Rice Farm Agriculture India Visualization. In India, rice is not just a crop, it's a cultural foundation and a massive economic engine. For millions of people in India, it is the most important part of their daily meal and a symbol of prosperity. Agricultural data in India, especially for rice farming, is vast but not easily understandable or visually accessible. My goal is to transform this complex data into an interactive, immersive, multi screen experience on Liquid Galaxy, helping users to explore crop patterns, farm regions, and seasonal insights in a much more intuitive way. This project, built entirely in Flutter, aims to bring this vital story to life by combining geospatial intelligence, immersive 3D visualizations, real time statistical insights, and AI driven storytelling that transforms the complex agricultural data into an interactive, navigable experience to show how rice connects different regions, climates across India, having a top-down hierarchical data exploration, starting from macro levels, national insights, and progressively revealing micro-level state-specific insights. The application acts as a smart controller and processes structured agricultural data sets covering vital metrics like yield production, rainfall, irrigation patterns, and crop growing cycles. Alongside historical statistics, the app pulls in real-time weather and temperature data. It dynamically generates synchronized 2D KML maps for the mobile device and 3D KML files with immersive extrusion for the Liquid Galaxy screens. Rather than just showing maps, the app converts statistical data into visual charts within Flutter, securely pushing them in the synchronized format as screen overlays into the rightmost LG screen. Integrated with the Gemini API, the app will feature a history mode that generates interactive narratives about the origins and evolution of rice farming in India, using automatic location extraction and synchronized immersive LG navigation. It also serves as a smart assistant available within feature pages to answer agricultural related queries given by the user in text or speech and triggers LG navigation when geographic references are detected and provide instant data-backed answers through text-to-speech. Lastly, this project is special to me because it seamlessly bridges the gap between raw, vital agricultural statistics and immersive storytelling. It doesn't just display numbers, it creates a dynamic voice navigated journey through India's most important economic engine. Thank you for your time.
Hello, mentors and fellow contributors. I'm Darpan Baviskar, a second year computer science student studying at Indian Institute of Technology, Jodhpur, and I'm here to present my GSoC 2026 proposal named LG Interactive Onboarding and Guided Tutorial and Learning System for Liquid Galaxy. Today I will walk you through why this project is needed, how it works, and why it is the right fit for Liquid Galaxy. Liquid Galaxy has grown into an incredible platform where new contributors come and learn, but new contributors face a steep learning curve. Documentation is scattered across various wikis and readmes, and some golden rules are violated again and again, but there is no safe space or sandbox for new contributors to practice. This leads to wasted mentor time, repeated mistakes, and slow onboarding of new contributors. My project solved this by creating a dedicated educational tool for Liquid Galaxy contributors, specifically for contributors only. The core idea is phone as driver and rig as a canvas philosophy. The phone becomes a very simple voice controlled remote control. All the AI educational content, 3D models, code examples, and interactive exercises are pushed onto the 5 screen panoramic LG rig. This respects the platform's architecture, the master slave architecture. All screens run Google Earth and they are synchronized along with each other. And also, the left screen shows the logo, and the rightmost screen shows the KML information. As you can see, all the interactive KML balloons and instructions, quizzes, and feedbacks are shown on the rightmost screen. The phone app is minimal with big buttons, high contrast, and voice first. You can say start lesson 3 or like verify my answer, and the rig responds to it instantly. All communication between the phone and the rig happens over SSH using the Dart SSH2 package, strictly following the golden rules. Whether it's a lesson diagram, a 3D model, or an exercise, it is written into the master KML's directory and propagated to all slaves so that they are synchronized over the LG rig. The app includes Gemini powered AI mentor. It includes question about Liquid Galaxy. It generates KML from natural language, like create a 3D skyscraper at Times Square, and it adapts user persona based on context switching between brainstorming, a code reviewer, or a skeptical mentor. Crucially, all AI requests use user's own Gemini API stored securely on the device. No central server, full privacy, zero operating cost at low scale. AI works with voice input and output, making it truly hands-free experience. This project is an educational tool built specifically for Liquid Galaxy contributors. It is not just another visualization app, but it teaches how to build for LG. It enforces best practices from day one through auto verification, preventing bad habits before they form. A 10 lesson curriculum is carefully sequenced from SSH pattern to your first own contributions to Liquid Galaxy. It democratizes 3D KML and advanced features that currently are under documented through a visual 3D model builder and dedicated lessons. It's a multimodal combining visual and auditory learning, and it takes care of privacy, your own data in your own hand, in the user's hand. And most importantly, this project is a community multiplier. It answers common questions, automatically teaches fundamentals, and frees mentors to focus on advanced topics. It makes the Liquid Galaxy community more accessible and sustainable. And I have built a Django based meme generator and a full stack diagram tool, so I'm comfortable with complex pipelines. And I'm also passionate about education and technology and open source too. This project combines system level integration of Flutter, AI, and real user needs with a clear scope and a realistic timeline. I'm in strong alignment with the Liquid Galaxy goals, and I'm really confident that I can deliver this polished, production ready onboarding tool that will serve this Liquid Galaxy community for years. Thank you for watching.
Hi Liquid Galaxy, this is Omar Sameh. I'm a third year student at the GSoC University in Egypt. My background, my technical background, I did many projects using Flutter and Dart specifically. I did many projects like e-commerce application, an Amazon clone, and a news app and audio player app and so many other apps. But the most related one to this proposal is a weather app. And it is related to this as this proposal is about flood risk visualization. So I worked previously with some weather APIs. It is in my experience. So the goal of this project is to solve real world crisis, because flood is very risky in many countries, especially in countries like Africa, because of the Nile River. It is the longest river, so it threatens many countries in its path. From one of those countries is Egypt, my country. So I think it relates to me so much and relates to my background. So this project solves a real world crisis, and how I'm going to do this project. So first of all, I'm using the climate data API to know where are the flood risks, and then when you select a place, it makes a 3D KML or a heat map with some like categorized based on the risk level. So you have low risk level, you have medium risk level, you have extreme risk level. So it's categorized by this, and each category of them has its own color that represents the severity. Like for low, the KML color should be blue, as it shows here in the mockup. For medium, it is orange. For extreme, it is red. And then here the AI comes in to storytell this risk by an AI voice, to storytell the how the scenario of the risk works, or how it happens right now. The next thing is why this project matters. Of course, it is a real world crisis, so it is very important to many countries. It is a global problem, especially in countries like my country. Okay, why am I a candidate possible for this? So I think mainly because it will not be a new project to me. I think it will be a project similar to some projects I worked on in the past, like the weather app. So I don't think it will represent a big problem to me, and I think I'm in the heart of the problem, or I'm in the heart of the crisis because of the place I live in. So I think it relates to me so much and relates to my background.
Hello everyone, my name is Ritesh Verma and I am from Roorkee, Uttarakhand, India. I am currently pursuing my BTech in Computer Science Engineering at Quantum University. While Liquid Galaxy is widely used for data visualization and have many amazing projects in that area, I really wanted to bring some fun to the platform by developing a game. We have seen games like Pac-Man adapted for it before, and I want to add another experience for the game lovers. My goal is to create a multiplayer game where people can play simultaneously and enjoy a truly panoramic experience on the large screens. The project I am proposing is multiplayer arcade game for the Liquid Galaxy. My goal is to create a classic arcade experience we all know and reimagine it as a large scale interactive event. Instead of a simple single player arcade game, I am building a collaborative and competitive system where the game spans the entire Liquid Galaxy multi screen setup. The best part is how easy it to join. Each player just scan the QR code and use their own phone as a controller, and you simply scan these QR codes and just connect it to the system instantly and assign us a paddle in the game. From a technical perspective, I have designed the system to be fast and responsive. I am using Node.js server to handle the physics, collision, and the core game logic. To keep the latency as low as possible, we are using WebSocket by Socket.io or real-time communication. The screen render the action using Pixie.js and WebGL, which allow us to stretch the game across the multiple displays smoothly. Uh, I have built the mobile app in Flutter, which provide the touch controller, haptic feedback, and the QR scanning interface. As you can see in the system architecture diagram, the system relies on a central authoritative server and real-time event flow pipeline. This ensures that the rendering stay perfectly synchronized across every screen in the rig. I have also focused heavily on making the experience stable. This includes lag handling and the stable interpolation, so the movement looks fluid even if the connection fluctuates. A room-based multiplayer system with smart reconnecting logic so the player can jump back in if they get disconnected. Ultimately, the data we are managing, like ball velocity, paddle movement, and the power-ups, is processed on the server and signed instantly, ensuring a smooth, scalable experience for everyone involved. To keep everything smoothly, the game data is managed entirely on the server. Instead of sending bulky files, we broadcast efficient data updates, meaning only send the changed data. This ensures that every screen in the Liquid Galaxy rig stay perfectly in sync. On the other side, Flutter controller sends user input like movement and actions, which are processed instantly to give the players that snappy and arcade feel. What really makes this proposal stand out is how it transforms Liquid Galaxy. We are moving from passive visualization platform to fully interacting gaming system. Unlike traditional projects that focus on displaying static data, this project introduces true multiplayer interaction, where real-time gameplay across multiple screens. Mobile as a controller, where a seamless scan and play onboarding using QR codes. And because this architecture is modular, it's incredibly scalable, supporting multiplayer and different game modes and future features. I believe this project brings a unique blend of innovation, technical depth, and long-term potential to the ecosystem. Thank you so much for your time. I am incredibly excited about the opportunity to contribute to the Liquid Galaxy. I am looking forward to your feedback.
Everyone, my name is Harsh and I am a third year student at VIT Pune. I also currently serve as the project head at IEEE student branch on my campus, and currently we are working on a hackathon portal for our college itself, so people can create hackathons and manage hackathons using our platform. Previously, we have also delivered a point of sale software for a client in Amravati city in the state of Maharashtra. So talking about the title of the project, it is Global Situational Awareness Dashboard for Liquid Galaxy. As of now, it has 4 to 5 major sources of information that will be aggregated. First is news, second is financial information, third is aeroplane, fourth is the ocean maritime traffic, and the fifth is satellite based traffic. The all the sources of information would be open source, and for news specifically we have RSS feeds which will provide information. So these are a few KMLs that are an example or an illustration of the kind of uh, use case this project is for. So let's say we have Strait of Hormuz, we have been hearing it a lot. So a user could query that, hey assistant, or hey whatsoever, please tell me about what's going on here. I don't understand a lot about what's going on in today's time. So it will first aggregate the user intent, then it will collect news and other sources of information like the maritime traffic in this specific case, and it will show you on the Liquid Galaxy using 3D KMLs and visualized tours that what exactly is this region and how is it affecting the maritime traffic, what happened when there was a blockade, or when that particular region was closed off, these many ships were stuck, and what was the financial impact that they caused. All this information would be displayed in the form of balloons, and the visualization would be in the form of 3D KMLs, which will be generated by AI. The LLM that will be used is locally running Google Gamma, and it will first identify the user intent and visualize things. Another example would be, let's talk about South China Sea. So if the user queries, please tell me about the history of Taiwan, why is there so many tensions between China and Taiwan, so it will first uh, query a web search and understand the history of Taiwan. Then it will produce a short script with because we will have speech to text and text to speech support, and once the script is prepared, it would prepare KMLs, and it would show you visually like a storytelling thing about what happened in the South China Sea, why was there split between China and Taiwan, and it will explain you the entire history. So this is a use case, and there can be plenty more use case, but the main special things for this project are the analysis of financial data and the news events. So these things make it a bit different from the previous year's GSoC projects for Liquid Galaxy. Thank you.
Hi, my name is Abhay Garunar and I am Liquid Galaxy Organization GSoC 2026 aspirant. I am a Bachelor in Technology undergrad in Medhavi Skills University, and I am currently pursuing Computer Science Engineering in AI/ML, Artificial Intelligence and Machine Learning specialization. And my project is basically the Victor Sanchez Mentors AI assisted 5-in-1 classic arcade game. So let me walk you through the mockups first. So basically, this on the screen is the splash screen of the Flutter app that I have designed using the Figma. So this stays in for around 3 seconds, and then the main game input, SSH input enters. This is where the IP address, port, SSH username, and SSH password basically have to be input for the connection. And this is the joystick. I have used the joystick because it can be used for all games, and I have installed two buttons. One is A and one is B. A is the fire button and B is the thrust button, and also two buttons. One is the menu and the home button, which will see what are the uses in the proposal itself. Moving on, I have created a lobby for the number of players to enter the game, and around 15 seconds the lobby stays in, and then the game basically begins. This is the game selection carousel basically, where you can select the game, any one game among the 5. You can select it basically using the joystick itself, and the A button that I told, which is the fire button, acts as the enter button to select the game. Moving on, these are the game mockups that I have created using the Figma. So Liquid Galaxy asteroids look like this. The live player score is displayed at the bottom of the Liquid Galaxy screen, and this is how the Space Invaders game look like. And this is the Snake game, and the LG Arthroid game, and the Bubble game. So basically, before the game starts in, uh, a interface that tells the rules for the players so that there's a fair competition. Actually, everyone knows the rules of the arcade game, but just for the namesake, we have created this interface. And then at the end of the game, basically the player with the most number of points wins the game. Each player is assigned a different color so that there is no confusion in the interface. And when the game winner is announced, the next interface would be to asking the player if he wants to play again. So the player who hosted the game have to select yes if he wants to play the game with the number of players he played before, and if no is selected, then it returns to the main game carousel. So this was it about the mockups. So about the AI usage in this is very minimal. I have designed all the mockups using the Figma, and I have used the AI for just the color coordination and which color palettes I have to use so that the interface can look a bit more interactive. And why my proposal stands out from the others is I have prior experience in the Google DeepMind game, and also I am a NVIDIA R2 Studio contributor, and I have also designed a prototype which you will see in the proposal itself. Basically, I have learned a lot about the project, and I have also I am also well known with the Liquid Galaxy Web Starter Kit made by Victor Sanchez, which I have also used in the Gemini Summer of Code. And that's it. So my name is Avay Gondonar, and I am a GSoC 2026 aspirant. Thank you.
Greetings team, I am Shaurya Mishra, student of SGSITS Indore, currently pursuing BTech in Computer Science Engineering from India. The project I am proposing is Living Flyways, Bird Migration Observatory. The aim of this project is to provide kinematic 3D visual shot of bird migration corridors on the globe on Google Earth with the help of Liquid Galaxy and amazing storytelling. Every year, thousands of birds travel thousands of kilometers in different seasons for their survival or to tackle a natural calamity. For example, big flamingos travel from Serbia to India every year to tackle harsh winters. The architecture of living flyways is going to be absolutely zero cost. For a Flutter app which is going to connect with Liquid Galaxy Rig via SSH, a server deployment on free hosting of Vercel.com, 7 different free open APIs which will provide us essential data of birds to make this project to bring this project alive. The deliverables of this project are amazing. First, immersive narrative experience with storytelling into a bird eye view of a bird model kept in a KML file and sent into Liquid Galaxy Rig, which will move along with the path of bird migration. Second, birds do travel in night time also. So a night mode with glowing cities and glowing nodes where birds stop with 3D orbit around them in the stop in their path and with 3D orbit around them, which will give us which will be glowing and a beautiful UI. Coming to the UI of the app uh, as well as the widgets are going to be amazing. Another one, historical timeline with population data. Historical timeline of migration we will get from birdlife.org API, where we will show how migration and the population of the birds has declined over the years or increased over the years. It just does not just show story; it will make you immersely live in it. Living Flyway is not just going to give you information, it is going to make you feel attached and live and fully utilize the virtual galaxy multiple rig to get into the shoes of a bird and actually feel how what they feel and what paths they took and what adventurous life they have to deal with every year. I'm very excited for this project. The project is very realistic. The task 1, task 2, and task 3 I have done with my mentors has provided me understanding of various scopes of Liquid Galaxy and how creative projects we could make. And the project is completely realistic, well under the scope of Liquid Galaxy, and it is properly implementable into the GSoC timeline. I'm really excited to work and contribute into the community of Liquid Galaxy and in this project, uh, and to get and to learn a lot under the mentorship of great developers. Thank you.
So hey, this is me Sanjay Sahu, currently pursuing BTech in Computer Science and Engineering, and I'm from Ajmer, Rajasthan. So I'll be proposing proposal on Glacial meltup application. This application is divided in 4 parts: glacial meltdown, sea level rise, precipitation, and ENSO. So I'll first be coming on glacial meltup. In glacial meltup, the users can able to see change in glacial mass across years. Like from 1993, they'll be able to see change in mass in 2025, and they can also change various factors like temperature, radiation, snowfall, precipitation. In sea level, now I'll be coming on sea level rise. In sea level rise, they'll be they can see how sea level change across the years, like, and they can also vary parameters like temperature. Now I'll be coming on precipitation. In precipitation, this module is divided in 3 parts: monsoon, uh, precipitation heat maps, and storm precipitations. So yeah, in precipitation heat map, I'll be showing for precipitation module, I'll be generating .tiff and then converting it into PNG files and then sending this PNG files through KMLs. So basically, I'll be sending KMG files, KML zipped files through the LG server. For this, I got the data set from NASA website, NOA, and GPM. Yeah, so for monsoon, I got the data from NOA. For precipitation heat maps and storms, I got the data set from NASA website and GPM. So last, I'll be coming on INSO module. For INSO module, I'll be showing change in temperature heat maps for in Pacific region to see how the temperature varies and see the cooling and heating effect of INSO. Yeah, so for visualization, I'll be using Gemini TTS. For AI integration, I'll be using Gemini TTS. It will be saying useful details like if this rate is followed, then the Earth glacier melt up will this XYZ glacier will melt up in 300 years, 200 years, etc., etc. And I also be using Google Maps API to sync my LG server with Google Maps. And at last, why I should be selected for GSoC. So yeah, I have good technical skills related to this project, and I have worked hard and consistent on my previous projects. And I also have very good interest in this project. So why this project should be selected for GSoC. So the problem with this, so we all have the problem to analyze the data. So the best way to analyze the data is to visualize it. So my project is more focused on visualizing the climate anomalies which are occurring inside on the Earth. So yeah, I'll be showing various kind of visualizations. So these are various mockups which I have asked. So this is the UML of my project. This is Glacier meltup on Liquid Galaxy. This is like both are Glacier meltup KMLs. This is sea level. This is also sea level. This is precipitation heat map. This is showing storm precipitations, and this is La Nina. Thank you.
Hello everyone, I am Ankit Yadav, second year student pursuing my engineering in Dronacharya College of Engineering, Computer Science under the specialization in Artificial Intelligence and Machine Learning. My proposal for 2026 Google Summer of Code is Climate Change Storyteller. So this is an storyteller app which will be giving an immersive and AI narrated experience to the user in the climate, that how the climate is changing in the past, present, and the future. So and my idea is like that the audience can literally time travel in the past and visualize that how was the climate in the past, and what is the condition right now, and what will be the projection for the future. So for the every project, the main thing is the data. So the data which is powering this project will be coming from the NASA and NOAA, which will be giving us satellite images and the temperature. And moving on for the future projection, we will be considering IPCC AR6 data, which will be giving us the future data. And moving on for the deforestation, we will be considering Global Forest Watch. We will be giving us the forest, what are the deforestation layer, and how they are increasing with time. And moving on for the air quality, we will be considering OpenAQ and EPA AQS data, which will be giving us the historical and the live air quality data from all around the world. Moving on, the main thing is, let me show you. These are the some of the mockups for the Flutter app. So our idea is, for Flutter app we will be considering both QR and the configurations also. And moving on, let me show you the concept. So we will be the Flutter app, we will be adding a slider which will be moving in the past, present, and the future, and showing the live visualization in the liquid galaxy as we will be considering the slider. So if I tell you more about how slider works, so instead of scrubbing a native time slider, the app sends a pre-built KML files each era over SSH, and the rigs will load it. And we will be considering, if I show you this app, the map also, which will be helpful to control the liquid galaxy also through the phone itself. And these are some of other mockups. So these are the mockups how the presentation we will be looking on the screen. So you can see the colored KML, 3D KMLs are there, showing how the glaciers are going on with the time. This is the air quality data, how the specific portion of the air quality is going. This is the deforestation mockup, and this is the rising sea levels due to the increase in sea levels, the rising floods or sea levels due to the glacier melt. So now moving on, I will be telling you that what are the data, how the data is coming, and what all the processes will be happening. So as we receive the data from the sources, we will be cleaning it and structuring it using the pandas and the scikit-learn. Then we will be creating a KML files which will be giving us a 3D orbiting view on the liquid galaxy, Google Earth. So now moving on, the main thing, which is the narration, as the storytelling is nothing without narration. So for that, the AI comes in role. So we will be taking a Gemini API which will be giving us the text for the specific location, and then we will be using the Google TTS to synchronize the text into the narration in the different voices. So yeah, at the end I will just like to say that let us show the people that how our climate is changing, and if we do not stop that, what all will be the projection in the future we will be facing. So yeah, thank you.
Hello, I am Khushi Dangi and I am pursuing my Bachelor of Technology in Computer Engineering at Thapar Institute of Engineering and Technology, Patiala, India. I have worked across front-end development, geospatial analysis and machine learning, and my proposal for GSoC 2026 is titled Glacier Melt Map, AI-driven glacial lake visualization. Coming to the problem, glacial lakes are rapidly expanding due to the glacier retreat caused by climate change. This is increasing the risk of GLOFs. While there are datasets that already exist, they are mostly in the form of shapefiles or static maps, which makes temporal analysis very difficult. So, with Glacier Melt Map, my goal is to convert this data into an interactive 3D temporal visualization on Liquid Galaxy, where users can actually explore how lakes have evolved over time. So, coming to the data set that I have worked on right now, this is the HIMAG dataset, which has multi-year glacial boundaries from 2008 to 2017. The multicolored layers represent different areas in different years. I have first performed exploratory analysis, which is looking at the boundary evolution and area change over time. And you can see how the overlapping polygons are showing the spatial expansion. Next, I process these shapefiles in and reprojected them. Also simplified the geometries a little bit and exported them into KML format for Google Earth visualization. So here in Google Earth Pro, as you can see, a comparison between 2015 and 2017 where the lake expansion becomes really clear. This is also an example of how it will look finally on the Liquid Galaxy rig, but in a 3D format. So on Liquid Galaxy, this will become a lot more immersive. The idea is to render these lakes that I showed as 3D polygons over the terrain, and also allow timeline based exploration, not just for historical data but also for the future. So here are my rig mockups. First, the lake close up view where a single lake is shown across the rig with the terrain around it. The second is the timeline visualization where the historical and predicted layers, as mentioned in the legend, are given to show how the lake evolves over the time. This makes climate data much more intuitive and visually understandable. Now coming to the Flutter controller, which is the USB. It is a mobile app that acts as the main interface for the system. Currently, I have connected this to the Liquid Galaxy VM that we made before, and I will now connect it to the rig. We here have region selection, and you can load the region on the rig. We have lake selection, and when you click on the lake selection, you will also be able to see the statistics and focus on the lake. We also have timeline navigation and data inspection. There are further features like alerts that will be provided in case of any GLOFs, and in the settings you will also be able to see further an orbit mode for automated camera movement, and we are also working on a story mode for the guided visualization further. And there will also be analytics panel which will be showing the lake area change as we have shared in the rigs. Coming to the AI part, which is a key addition in my proposal, along with the historical visualization, I have also planned to further integrate a PyTorch based ML model that will predict future lake extent, and it will take shapefile data and then generate polygon geometries. This proposal is not supposed to not just be a visualization tool, but it's supposed to be a decision support and also an awareness platform, which makes it very different from which adds a strong dimension to the project. And overall, Glacier Meltmap aims to make this complex glacial data much more accessible and interactive. Thank you.
Hi, I'm Syed Jaswal, a BTech Computer Science student from Dronacharya College of Engineering, Gurugram. I'll keep this real. This didn't start as a GSoC idea for me. It started with something that bothered me. We always talk about saving oceans, but we never actually experience what's going wrong inside them. And I felt maybe that's the problem. So I am trying to build Aqua Sonus. Aqua means water, Sonus means sound. So basically it translates to the voice of ocean. And the idea is simple. What if people could actually hear the damage we are causing? Not just see the numbers, but actually feel the difference. So in this app, the user doesn't see a map. They tap on ocean region, they see noise levels, but most importantly, they can actually listen. They can switch between a clean ocean and one with heavy shipping noise. And that one moment when the audio changes, it hits differently. It is the moment of realization. I also added marine life layers, so when you see a whale migration path crossing with a noisy shipping lane, it just stops being data. You start seeing as a conflict, and I take this to Liquid Galaxy because there's where it becomes immersive. On the 5 screen setup, you can actually see shipping movement in real time, noise spreading across oceans, and communication zones getting disturbed. And then you try solutions, be it reducing ship speed or rerouting the traffic, and you literally see the ocean calm down. That visual change, that's what makes it stick. On the technical side, I'm using AIS ship data and OAA datasets and marine species data, converting all of them into KML levels, layers, and then for the Liquid Galaxy. Flutter is a really big part of this. I've already worked on a Flutter application for a government-based project, so I have real experience building scalable apps. But for this project, Flutter helps me create a smooth, real-time interface that connects well with the Liquid Galaxy. I'm also using AI mainly to guide the user, to explain what they are seeing, highlight patterns, and make the whole experience feel more like a story and more like a something documentary thing, not just a dashboard. What I really care about here is I just don't want to show the problem. I really want the people to feel it, to experience it, and understand that even small changes can make big differences. Now the question arises, why me? Because I'm already invested in this. I've designed multiple screens for the Liquid Galaxy setup and mobile in detail. I've thought through the flow, the experience, and how someone will actually interact with it. And I genuinely want to build this not just for the GSoC, but because of genuine cause, and because I also believe in this idea. If selected, I won't just complete the project. I'll make sure it's something people remember after seeing it. Because the ocean is not silent. We've just never heard it before, like we will now. Now let's see the mockups. This is the first LG screen mockups. All the LG screens here will consist of five screens, and the centermost screens will basically the Google Earth visualization. The cornermost screens will be the analysis ones. Now this is the noise map one that helps us to see the noise levels. This is the marine life migration and communication map. It helps to see us the migration paths and their communication zones. This is the noise map again, but this is for a 24-hour cycle. This helps us visualize the 24-hour cycle of oceans, how noise changes with time. Now coming to the app screens, these are the app screens. Now let us navigate through them. This was the home screen. Now this is the first screen that the user will encounter. Here are the bunch of options they can choose from. Live monitoring will move them here, and they can actually explore through historical data as well. They can just navigate through January to December and through years as well. Now coming to ocean stories, they can go to this. It will make them go through this, and here they can go through multiple chapters, and of course it has the AI voice narration. Now coming back and exploring regions, it is the screen that will pop up. Now for example, here it is the North Atlantic region. Here they can see noise level, main noise source, etc. Next screen is the marine life information. It provides information about their species, communication frequency, their migration routes. Now coming to the dashboard things, it takes account of multiple things like shipping density, sonar activity, drilling operations, etc. to make the dashboard. Now coming to solution simulation, it is my personal favorite. It just shows how can we cause for a solution. Here we can reduce ship speeds, reroute lanes, and include quiet zones, and see if we have reduced the noise by 12 decibels. Now it is the last and the setting screens. The user can from here can see choose from multiple data sources, audio settings, etc. and they can change the language, and they can see more about the project. Thank you, and I'm really looking forward to contribute to this project.
Hello everyone, I'm Sana Bhattacharya. I'm from Kolkata, India, and currently I'm pursuing BTech in Computer Science Engineering from National Institute of Technology, Durgapur. And today I will be presenting my proposal for Liquid Galaxy titled UNESCO World Heritage. UNESCO World Heritage Sites represent a shared cultural and natural legacy, but traditional maps fail to capture their scale and significance. This project aims to transform static exploration into an immersive experience by enabling users to virtually travel and interact with these sites using the Liquid Galaxy screens. This application is built in Flutter using clean architecture for scalability and maintainability. It generates synchronize 2D and 3D dynamic PMLs using open source geospatial datasets and official UNESCO datasets and integrates real-time weather information. A synchronized screen overlay displays site details alongside 3D view. And along with this, for quick access for the users, a home screen widget is also enabled with this application to control the Liquid Galaxy rig. One of the core pillars of this application is how it leverages artificial intelligence to enhance the educational experience. The project integrates the Gemini API to power a story mode that generates engaging narratives about each site. It also functions as a smart assistant, easily explaining its history, culture, and nature. By connecting to the Gemini API, the app features a story mode that creates engaging interactive stories about the cultural importance of each UNESCO site while automatically moving the Google Earth view to match the narrative. It also acts as a smart assistant that answers user related queries through text to speech. When AI provides instant answers out loud using text to speech, it simultaneously passes the geographic context to automatically fly the liquid galaxy to the places mentioned in the conversation. This project uniquely combines geospatial visualization, AI-driven storytelling, and immersive multi-screen interaction. It introduces accessibility through a home screen widget and creates an intuitive educational platform that goes beyond visualization, transforming the Liquid Galaxy into a global storytelling system. Instead of just looking at plain maps, the users get an immersive interactive experience where they can virtually travel the globe. And lastly, by combining reliable official and open source datasets, synchronized 3D rendering, accessible UI widgets, and AI driven storytelling, this project creates a truly transformative educational experience for the Liquid Galaxy platform. Thank you for your time.
Hi Liquid Galaxy team, I'm Samatma Evaradwaj, a second year undergrad student pursuing my BTech in Computer Science and Engineering at PES University in Bangalore, India. I have experiences on working on past projects using Java, Python, C, C++, Flutter, and MERN-Stack. My areas of interest particularly lie in cybersecurity, AI, and UI or UX design, especially where complex data needs to be made more intuitive. Now, coming to the idea of my proposal, let me start with a simple question. Why is England warmer than other places at the same latitude like Canada? Or why does monsoon behave so differently across different parts of the world? Or why does Kerala in India receive extremely heavy rainfall whereas Rajasthan remains relatively dry? The answer lies in systems which we don't directly see, which are ocean currents, atmospheric winds, and climate oscillations. But here's the problem. We usually learn these through static representations like static diagrams or text, and that makes it really hard to understand how these systems are actually interconnected. So, what if we could explore Earth's climatic system like a live system instead of static representation? And this is exactly what my proposal aims to do. My proposal is titled Earth System Explorer Immersive Visualization of Global Climatic Processes Using Liquid Galaxy. What you see here is not just visualization, but it's an entire control system with immersive storytelling for exploring the planet. Let's say the user selects El Nino effect. On selecting El Nino effect, the system moves across the Pacific. It shows temperature anomalies and it shows the impact caused by this effect on landmass as seen by drought and heavy rainfall symbol here. So instead of actually reading about it, you get to see the closest thing to actually seeing El Nino happen. When the user selects Gulf Stream, a warm Atlantic Ocean current which flows from hotter region as depicted by red colored arrows to colder regions as depicted by blue arrows flows, and then details dashboard about the Gulf Stream is given on the rightmost screen. And then you can also see the effect of a particular ocean current or a wind stream or any other earth system on a particular city, as here seen is the example of the effect of Gulf Stream on the city of London. This image depicts El Nino effect. This image depicts La Nina effect, which is the opposite of El Nino effect. And then this is the Indian monsoon system. It illustrates the seasonal rain-bearing winds flowing across the Indian subcontinent. It also helps us to answer the question of why Kerala in India receives heavy rainfall, whereas other parts like Rajasthan remain extremely dry. And then this denotes the effect of Indian monsoon on Indian city of Mumbai. This depicts Kuroshio current, which is a regional warm Pacific Ocean current And then lastly, this is jet stream, which is a warm upper atmospheric wind stream which impacts weather across continent. Now coming to the datasets used, I aim to use for my proposal are mainly two datasets, which is one is National Oceanic and Atmospheric Administration and NASA Earth Science. Now coming to how this system actually works uh, is two components working together. One is the Flutter based mobile application where the user interacts, and then the Liquid Galaxy rig where everything is visualized and comes to life. So when the user selects something, the backend processes the data, converts it into KML layers, and then sends it to Liquid Galaxy, and then triggers a guided tour across screens while also having immersive storytelling using Gemini and DeepGram, and it also syncs with Google Maps in the mobile application. Now coming to the AI usage, here's where things get more interesting. What if the system could explain itself while you explore? That's where AI is used. AI is used to generate real-time explanation using Gemini and provide voice narration using 11 Labs or DeepGram. So AI helps to turn complex climate systems into a clear structured story so that users get a guided experience. So what I feel makes my project special is instead of showing one data set in isolation and without context, it interconnects everything. It shows how oceans influence temperature, how winds affect rainfall, how global systems impact local weather. So it answers the question of not what is happening, but it answers the question of why is it happening. So it makes it a platform for exploration, education, and scientific storytelling. Now, I'm extremely passionate about this idea because it combines real world data and strong technical design and an intuitive user experience to fully utilize Liquid Galaxy's potential, and more importantly, it helps people understand the massive phenomenon happening throughout our planet. If selected, I have a realistic timeline in which I plan to implement my proposal. If I'm eager to contribute, if I'm also extremely eager to contribute to Liquid Galaxy's great community and learn from amazing mentors. Thank you for considering my proposal.
Hi everyone, my name is Aniket Dhingra and I am a computer science student from India. Today, the proposal I am going to talk about is shared Liquid Galaxy experiences. This project focuses on making Liquid Galaxy more collaborative, accessible, and interactive by allowing users to create and share visual experiences across devices. Right now, the problem is Liquid Galaxy is incredibly powerful for visualization, no doubt, but it is mostly single user driven. There is no simple way for someone to create an experience, share it with others, and have them instantly visualize it on another LG rig. So the goal of my project is to build a system where users can create KML based experiences. It will generate a shareable link and also allow users to instantly load and visualize that experience. So this will transform the Liquid Galaxy to a more collaborative and a more accessible work platform. So let me explain the core workflow. So let me explain this by using a simple example. Let there be a user A which will create a visualization. Let's say it uploads a KML file on the app and then a shareable link is created. Then the user B will receive that link, and using the controller app, the link is decoded, the KML file is fetched from the backend and then sent to the Liquid Galaxy rig via SSH. Within seconds, the same experience is reproduced on another system. This makes sharing fast, scalable, and seamless. Now let's talk about the system architecture. The system is mainly divided into three main components. First is the Flutter controller app. This app is used to paste or open shared links. It manages LG connection via SSH and sends commands and loads the KML files. The second component is the backend, which is implemented using Node.js, Express, and MongoDB. This will store the KML files, it will generate the shareable links and handle the retrieval and the decoding of those links. Third is the Liquid Galaxy integration. Uses SSH commands, loads KML via network links, executes navigation and visualization. So this architecture ensures that the system is lightweight, scalable, and also compatible with the existing Liquid Galaxy workflow. As you can see, I have some app UI UX mockups behind me. So let me show you and let's go through them. So the first tab is the home tab. As you can see here, we have some quick actions so that the user can just on a click switch the tab. Then we have the My Experiences tab, where the experiences created by the users are displayed here, and they can also visualize them using this play button on their own rig and also delete them. Then we have the Upload tab, where the users can drag and drop their KML file, and it also asks some of the description of the experience that they have created. And then after clicking the upload and the save button, a shareable link is created. This is the settings app, where the users can connect their own rig using the QR or the credentials. And lastly, this is the Share tab, where the QR code or the shareable link is created of the KML experience. So we can also download the QR or share it via many apps. Now let's talk about why this proposal is special. What makes this proposal stand out is that it solves a real limitation that the Liquid Galaxy has. It introduces collaboration, users can share experiences easily, scalability, works across multiple LG setups, and lastly, usability, simple link-based workflow. This is not just a concept, it's highly practical and it can be implemented within the GSoC timeline. Also, it builds directly on the existing LG infrastructure like SSH connection, KML rendering, and network links, which makes it both innovative and realistic. I'm really excited about the potential to contribute to such an amazing project, which will make Liquid Galaxy more accessible and more collaborative at the same time.
In every project, every song, we find our voice. United by technology, we celebrate our choice. With mentors and creators, we build a legacy. A future filled with promise in the Liquid Galaxy. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide. In the Liquid Galaxy, our dreams and worlds collide.